Yo, whoa, I can hear myself. Hold on, give me a second as usual. It's good to see everyone. I'm glad we're back. I don't like it. I can hear myself in my own headphones. Give me 1 second. I'm learning how to do this again. Let's see. Properties. There we go. I fixed it. Can you hear me? Can you hear me? Is the music too loud? I'll definitely turn the music down as we get going. But we got to get hype a little bit coming on in. What's up, everybody? Good to see you all. I'm hype. It feels real good to be back. First time checking in. What's up? I'm Zatcher. Oh, I got to make this larger. So today's going to be, luckily today is just syllabus day. Not just syllabus day. This is the start of your journeys. But I actually called an audible on this a little bit last minute, not the class itself, but where I was streaming it from, the system that I'm streaming it from. So I was trying to get some last minute things together because I wasn't able to move everything over immediately, but it's good to see everyone. What's up, Snowmad? Good to see you. Who else we have? JML. I gotta make my font bigger. I got a lot going on here. What's up? Laugh now, cry never. Good to see you. Joey's Bites. Good to see you. Twin Cities. Good to see you. Actually, I don't think it's the Twin Cities. My mind just went too fast here. The witticisms. I like it. MB. Good to see you. Yes, we are learning GOLANG. It should be great. What's up, Rue? Absolutely. Glad you joined. Glad you're coming through. We're going to talk about everything we're going to be doing. What's up, Benjamin? Good to see you. What's that? Garbo McStevens. I like it. We in here. I love to see it. What's up, Naughty Body Wash? I love the names. Clever Dorothy, is amazing to see you. Hope everything's great. What's up, YGBSM? Blast from the past. Good to see everybody. What's up, John Vagabin? Did my best. Hopefully I got that there. What's up, Afrocoder? Good to see you. Moan, Gluon, good to see you. Shred Ghoul, all the OGs. Welcome. How you doing, Snowmad? And what do we got? D Thompson, what's up? Good to see you. All right, so one, you can hear me. Music's not too loud. Excellent. I'm in my office. You can't really. I haven't moved the scene over to Zoom back. Definitely tomorrow I'll have all the scenes here. I was gonna do this actually from my house, but the upload speeds here are much greater than they are in my own home, and more consistent and more reliable. My system here is also much beefier. If you look down in the hardware section, I'm streaming from a monster of a computer, but it's amazing to be back. Yeah, so you might be wondering where I've been, what I've been doing, and life. I've been doing life. Life's been really good because of things that we did in the past here. I was able to actually teach an in-person software engineering bootcamp, which was pretty fun. It was pretty dope. Learned a lot. It's definitely much different being in person, but it was super dope getting to meet lots of new people, to go with them through their journey. And actually, I spent part of today helping two people who actually got roles right after that bootcamp was done. It was like a 25-week in-person boot camp, software engineering and software testing with a nonprofit here in Baltimore called Betamore, and it was super duper dope. And so that's the biggest place that I've been. Mostly, we tried to actually stream that. We streamed the first couple of classes from that, live in-person classes, but the bandwidth actually in the building wasn't actually enough to stream. Some things happened and it made it difficult because of COVID. We had to go to a hybrid model as well, so we were also like zooming it up and all this other stuff, and so it got to be a little bit too much to be able to stream that, and so unfortunately we had to stop that. But that is over. It was super dope. Hopefully it'll be happening again. We're in talks now to make sure that happens again. I probably won't be teaching the second round. I wanted to teach the first one to learn kind of the different things at play, because there's a lot there's a lot that goes into teaching a class and helping people get jobs and things like that. So definitely a good learning experience. But yeah, hoping to bring some things that I've learned over here. But yeah, also for those of you who've been around for a while, the baby has now turned 1. She's doing great. She's running around, super grown. You will see her guaranteed many times. She'll be around. She's usually in the office here with me. Mrs. Mastermind is doing amazing. My wife is doing great as well. We just purchased our first home, which was a hassle. Still moving, still doing all that stuff. So that's been pretty dope as well. So just blessed. Business is good, work is good, everything is good. I cannot complain at all. But I've missed this. This is what I've missed the most. Being here with you all, streaming, sharing, having a good time, learning, growing together. And so, yeah, that's what that's what we'll be doing. What's up, Berserk? I love it. Good to see you. First time chat. Good to see you. Yeah, everything. Seriously, everything is great. You know, as a new homeowner, we've been in the house for 2 weeks. Tomorrow will be 2 weeks, and I've learned a lot. You know, I had to, you know, what little bit of money I was able to save during the process, I had to spend on a lawnmower, and you know, now I got to do adult things that I don't want to do quite as much as you know. I don't really want to do it, but it's all good. I got to figure out why the chat is going away from the screen so quickly, but it's all good. We'll figure that out as well. Yes. What's up, Ari Winokur? Yes. Unfortunately, the puppy, for people who didn't know, not to bring some sad news to the channel, but Maya, the puppy, she did pass in the middle of the end of lockdown. I guess over a year ago at this point. She did have cancer, but you know, it's life, the joys and the pains of pet ownership. But yeah, we had a baby. She's over a year old. Wild times, definitely wild times. All right, so today let's get into it. Let's get through it. First things first, you know, like I said, I'm just trying to get comfortable being back. It's super nice. We do have some slides. If you have hit ! Register, or if you already registered, you probably already have this, but if not, if you hit ! Code Classroom, it will take you to the Google Classroom for this course, the Google Classroom that we're gonna be using for this course, and you can get the slides from there. But what I will do is I'll copy this and I will make a slides command right now. Let's add or edit. That's already one. Edit slides. All right, so now you should be able to do ! Slides, and you should be able to get a link to the slides. For anyone who's new to Twitch, who doesn't really know what's happening with these commands, these exclamation points and all the other stuff, we'll talk about that. You will know what it is. I'm not gonna leave you hanging at all. So you'll definitely know what's going on here, but it'll take you to the slides if you want to follow along, but also you can just watch it on my screen. I'm going to share it. Today will be pretty much the only day that'll be hands off. Yeah, it's gonna be the only day that's gonna be hands off. Those classroom codes don't work, MB. I need to remove that classroom link. Those are very, very old. It will let you into older classrooms if you want to get in there, but for this one, it is Code Classroom. If you're going to be in tomorrow's, it's going to be Cloud Classroom for that one, so you will have different classrooms for each of the different classes. But first things first, you know, you all know, the OGs know that I'm a terrible typist, and I've been getting better. I've been practicing. I want you to see something really quick, because I've been getting good. I've been getting better out here. Not good, but better for sure. And so I'm gonna log in really quick. I got to show you something just so I can get comfortable here. And let's see, which email was it? I think it was this one. Let me get logged in here. GOLANG is only during Code Classroom. So MB, kinda. It is specifically during Code Classroom. We won't be doing any Go in the Cloud class. We will be doing a condensed entire GOLANG course in the DevOps anthologies. That's going to be taking place on Thursdays, and I think that's going to happen in like 8 weeks or so. We're starting with Linux, but I think in like 8 weeks or so, we're going to be doing a condensed GOLANG course in there. If you want to hop into that. So we will be doing some Go there, and we'll actually be using Go in there throughout that course. But yeah. So when I left you all last time, I'm an okay typist. If I was looking at the keyboard, I was a terrible touch typist, in the 30 to 40 words per minute range. You know, I got fat fingers and I have a little keyboard. Okay, a little 65% keyboard. And so, you know, I had some struggles, but I've been getting a little bit better. And so to get my woes out, I've been watching, you know, I've seen Prime and all these other amazing 120 words per second people doing some dope stuff. I'm gonna just slowly, you know, one word at a time, get caught up with you all, just show you, you know, maybe on beat. Let's turn the music up a little bit. Ooh, group, during. Oh, see, I'm getting shy already, but you know, I just want to practice a little bit because I'm going to be typing a fair amount today, and you know, I just want to show you all that I've been working hard. I'm bad at stuff, but you know, you can get good if you want to get good. Oh, Oh, so so 51 not good. I messed around in the beginning, but I want you all to know that if you've been around for a while, that I'm better. I'm better now. So actually, so if you look back at my actual scores, look at this: 83, 74, 67, 63. I'm getting there. I'm shooting for that 100 words per minute mark. I'll get there eventually. Call me Queen Bee. The code for the classroom is !. If you type in ! Code classroom, it'll give you a link directly to that classroom. So if you click on that link that was just shared by Nightbot, it'll take you right to the classroom, or at least it should. Let me know if it doesn't take you directly to the classroom, but it should let you. It should let you be able to see that. What's up, Sin City? Good to see you. Also, one thing that's different about this class as opposed to past classes, I'm gonna hit all the followers. Thank you everybody who's followed, appreciate it. Good to have you. Welcome to the community. Any type of alerts and donations, I turn the alerts off so that it would be a much more I don't want to pull anybody out of the learning experience, so I will see them. I will thank you. I do appreciate I appreciate everybody wholeheartedly. But it's not gonna pop up on the screen, and I will fix the chat window. Super duper weird. Like I said, I'm moving over to this computer for all the streaming. I actually don't have any other scenes on my computer right now, which is kind of weird. Still making custom keyboards? Yes, I am, but I refuse to make one with bigger keys. I want to get good with this one. As soon as I hit 100 words per minute, probably on the 30-second typing test, I will go for a bigger keyboard. What's up, Baraka? The streams will be about 2.5 hours every day. Some will be 2, some will be 3. So 2.5 hours is what I would plan for. And that's what we'll be going over. The time we'll be aiming for. This course, as opposed to previous courses, will be much more hands-on. So part of the time we'll actually stop and you will have time to do some hands-on things yourself. So feel free to, expect that you have to do work during class. Yes, there should be one thing posted in the classroom right now. It should just be slides in the Camp Cloud classroom. It's funny because on this computer, so I do a 2 PC stream. This is a pretty bare bones computer that I'm working on right now with almost nothing installed. So I'm not logged into anything. But yes, I do see that the slides should be available in Camp Cloud right now. You can also hit ! Slides to get yourself going. YGBSM, I appreciate it. Really, really do. Thank you so much for the sub. Good to have you. Reset button push. What's up? Good to have you. All right, so let's get going. Give you some of your time back. Everybody's time is important. My time more than ever. I now understand the value of time. The baby will be asleep when I'm done, but that's okay. We'll spend a lot of time with her today. I like being able to, move my stuff around. Yes, VODs will always be available if you miss class. So they will be on Twitch for 60 days. They stay on Twitch for 60 days, so you'll be able to come right here and see them. I have a YouTube channel that I usually put them on. I have a brand new YouTube channel that I'm still setting up, but I already have the email and stuff for it, but there's going to be a mastermind rewind basically channel for you to watch all of the VODs. So yeah, Hype Train, again, it's so new. It's so new. I'm just refreshing myself. Thank you so much for all of that. Throw some emotes out there or something. I got to get back in it. It's J Fields. Good to see you. Thank you so much for the sub, man. Thank you so much for the support. Callow, it's good to see you. Yes, Callow, I did have a baby. You didn't come through to the baby shower. We had the baby shower right here on Twitch. It's good to see you, man. I was actually in your stream the other day and I was gonna say something, but it was super late and I wanted to go to sleep, so I didn't say hi because I knew I would have ended up staying on for a lot longer. But it's amazing to see you. Yes, she's over 1. She's 13 months. Is that what parents say? I still feel like a child, to be honest, so it's kind of weird to say that. I don't know who allowed us to have a child, but yes, thank you so much. All right, let's get to it. Let's get right in it. Slideshow. Here we go. Okay, so welcome to Base Camp. All right, welcome to Base Camp. Welcome to base camp. You say it a bunch of times. And so base camp, for anyone who's been a part of anything before, who's been a part of any of the journeys, who's been a part of any of the excursions, base camp is going to differ because base camp it's a foundationals course. All right. So before you go climb a mountain, you got to go set up camp. Base camp is going to be where you get yourself together, where you're going to eat, where you're going to stay warm, where you're going to have resources, where people are going to begin their climb from. You actually set them up a couple of times along the way. Sometimes you can get to a new plateau and you can set up another base camp so that if you need to come down, you can do so. But this is going to get us prepared for a bigger climb later. So this is going to be a very deep foundationals course. So before we did decoded, and we learned how to code, and we're going to learn how to code here, but we're going to dive much deeper into the computer science concepts. We're going to dig much deeper into the algorithms and the data structures than we have before. We're going to try to build a much stronger foundation than we've ever built before, and that's going to be the goal. Thank you so much, Cammy Hudson. Thank you so much for the 100 bits. Good to see you. Wait, Laylar. Is Laylar, did I remember that right? It's good to see you. Really good to see you. Yes. Oh, congratulations. Congratulations on the baby. That's dope. I hope you're getting some rest. I hope you're getting some sleep. I hope everything is going well. Seriously, that's super duper dope. Congratulations. But yeah, we're going to get you a really, really, really good foundational level of knowledge in these things. So this is going to go much deeper than the apprentice level of Decoded went. Same thing for Camp Cloud. If you're in the Camp Cloud tomorrow, it's going to go much deeper than we went in the apprentice level of Horizons, a whole lot deeper. Also, all the courses are going to go much deeper, but it should make you better on the other end. Group projects, so there will be projects. I hope if you want to do them together, you're more than welcome to do them together. That's a good idea, actually. Sleep, exactly. I'm super fortunate. My baby sleeps for the most part. She does wake up, but if she gets fed or if you just make her comfortable, then she goes right back to sleep. But yeah, I've been doing pretty good in that aspect. All right, so Camp Code. This is going to be the start. So this course is for if you're brand new to this. If you don't need to know anything, we're starting from scratch. You don't need to know anything. It will feel uncomfortable. Just telling you right now, we're going to talk about getting comfortable being uncomfortable. It's going to be a ride, but it's going to make you much better on the other side. We'll talk about the types of jobs you can get. We'll talk about the money, all these things. Okay. So who am I? If you've already seen this, I haven't updated this slide because most of it's still true. But my name is Aaron Brooks. AA Ron, feel free to call me AA Ron if you'd like. But my name is Aaron Brooks. I'm a DevOps engineer, technical lead. I've done all these things, business owner, all these things with about 12 years of industry experience. I'm 32 years old. Damn, I'm getting old. 32 years old. I haven't said my age in so long. I know that's not crazy old. It's not crazy young either. But I did go to school for tech, but we'll talk about that. I didn't finish school, but went to school. Got my first job at about 20 years old. So that's why it's around 12 years. I'm a 90s baby, born in 1990. I have to throw it out there because of the type of humor I'm going to use, the type of things that I like, the ways that I feel. I think it's important for you to know that. I love cars and motorsports. This has grown. This has been something that's grown since last time you see me. I love it. I love to race, truck in a trailer, take my car to the racetrack. I spend the little bit of free time that I do have, I spend it driving back roads. In fact, the house that we purchased is right next to my favorite back roads, in Maryland. So it's pretty dope. I would claim I'm a gamer. I'm definitely a gamer. I love to game. I don't really play any games anymore because of work and business and all the things that I have to do in the baby. I don't really play many games anymore. I don't even play Overwatch anymore, but I'm always going to be a gamer at heart. I pretty much only play my Nintendo Switch right about now. But yeah. I'm going to catch Ozark. I've been so busy, I haven't been able to catch it. I love Ozark, one of my favorite shows. What do I drive? So I'm a big fan of slow car fast. Not fast car slow car fast. So I have a BRZ TS, that's what I track. And I drive it around a little bit on the streets. I actually drive a slightly modified Mini on the streets, like for back roads driving and stuff. And that's my commuter car with gas prices that are super high, because I also have a F-150, so I have a truck and it guzzles gas. And so, you know, my Mini is my daily, and it's a really good fun back roads car. But I drive the BRZ ETS on track, mostly because that's the type of car I can afford to track. Consumables are cheap, all that. But yeah, yeah, it's wild that I've had a lot of cars over the years, and to me it's weird that I'm in these like lower powered, slower cars, but I have a lot more fun in them. You know, it's fun not spinning out and crashing on the roads. You know, it's pretty nice. But I love watching movies. This is like my favorite thing to do. Horror movies are definitely my favorite genre to watch. I'm an Android Spotify user over iOS and Apple Music. That's just say I'm an Android guy, you know. But I do have an iPhone. My main phone is an iPhone. My business phone is an Android. It's a Pixel. So I do use both. I'm not an Apple hater at all. I promise you, I'm not an Apple hater. But that's my preference. Pancakes way better than waffles. French toast greater than both of those things. And dogs, I like dogs over cats. I like cats. I've had cats. I do like cats, but dogs are better than cats. And now you know me. You know who I am. You know what I like. Had an S2K. I would love an S2000. I would love an S2000. Yeah. So deer are a problem. It is something that scares me. I've been super fortunate. I haven't had any run-ins. I had a Fiesta ST where a deer ran into me. I was driving pretty quickly on some back roads, but the deer actually ran into the side of my car, and so that was fortunate. But yeah. I miss my Subi. I had a WRX for a little while. Love Subis, special place. Well, I have a Subi now. I always forget that I have a Subi now because WRXs and, you know, STIs are they're my favorite, just not for what I do with cars right now. I would love the GR Corolla, but I can't afford any more cars, and my wife would kill me if I got another car ever. Yeah. Let's see. Uptime. I haven't been on that long. Rug Matt. Looks like we have a raid coming in. I don't know. Maddie, Two Shoes. Thank you so much for the raid. Come on in. People who are not familiar with Twitch, a raid is when another streamer, another community brings their folks, when they're done their stream and they're all wrapping up, they bring their people over to another stream. So thank you so much, Maddie Two Shoes. Let me see if I remember how to do a shout out. Let me see if I can spell your name correctly, because I always mess this up as well. Maddie Two Shoes. There we go. Dope. Thank you so much. Welcome everybody from Maddie Two Shoes' channel. You're joining us on the first day of a software engineering boot camp. We have a cloud engineering boot camp starting tomorrow, and we have a DevOps anthology series starting on Thursday, where we're going to start with Linux, and we're going to touch pretty much all the major tenets of DevOps if you want to come through. So welcome. Thank you so much for coming through. So now you know who I am a little bit. Feel free to ask any questions. You want to start any conversations, you know, now you got something to work off of. This is who I am. So just like I said, for anyone who's not familiar with Twitch is a game streaming platform, but they allow you to do a lot of other things on here. You can come across some weird stuff if you're really looking for it, but anything that really your heart desires, you can kind of find on here. But it's owned by Amazon. So if you have a Amazon Prime account, you get a Twitch Prime subscription. Subscriptions are ways to support streamers. So you can look that up if you want. We're not here really for that at all. But the reason we're on Twitch is because of the interactivity. You can make it a good time. You can do things like raids. You can make chat bots to do some cool things. You can do all that stuff. That's why we're here. So if you're unfamiliar, when you see people typing in those exclamation points with the words after that, those are chat commands. So that's a way for you to self-help, for you to get information on your own or asynchronously. So we'll set up commands so that you can do so. Exclamation point slides is one of them if you want to get the daily slides. We can set up any type of command that we want. If you hit exclamation point commands, I think it might give you a commands list. There's a bunch of old commands in there that I haven't cleaned up, but you can take a look at it. Primarily, I mentioned you get two pretty dope people. If you all are not following, we'll definitely raid Prime. Leon usually finishes before me, but we will. Leon's super dope. He teaches here on Twitch as well. Right now, I think he's doing an HTML, CSS, JavaScript, like web development boot camp. I'm not really a good web developer, so feel free. I'd love for you to follow these dudes. Prime works at Netflix, amazing, super entertaining person. You should explore Twitch. You should find other people, other resources to learn from, because it's not just about the educational content. People are building really cool things, and you'd be surprised at how much you'd learn through osmosis, through just hanging out and talking to people. It's pretty dope. 1 session per week per camp, but you will have more to do outside. Usually it's 2 times per week. It's once per week, but you'll have more work to do outside of the course itself. You have more time to practice. You'll be given what there is to practice. So yes, Camp Code always be on Mondays. It will always be on Mondays. Camp Cloud always on Tuesdays, and the DevOps Anthology series will always be on Thursdays. All right. So methods of communication. If you register, every week at the beginning of the week, I will send out. If you register, it'll subscribe to my mailing list. At the beginning of the week, you don't have to subscribe to the mailing list. That's all registration does. But what it'll do is it'll allow me to send you at the beginning of every week. I'll send you out class schedule. If we're skipping a class, if there's going to be weeks where things have to happen. There's going to be holidays, all kinds of stuff. So I'll send out something at the beginning of the week, letting you know what days we're doing things, what times we're doing things. It'll always be at the same time. It'll have topics. So if you want to know what the topic for the week is, to figure out if you want to come through or not, you'll see that. So that's a good way of knowing what's going on. It's a good way of keeping up. I will not spam your email. You will get 1 email at the beginning of the week, every week. Discord is going to be the second best place to find out information. Hopefully that Discord link works. If it doesn't, let me know. The invite should still be active. Discord is like Slack or Microsoft Teams. But that's where I'll update with information as well. If there are changes, or at the beginning of every week, all of the information will go there as well. You can also follow me at Twitter or Instagram or LinkedIn, everywhere at Mastermind.io. Mastermind does not have an I in it, so it's Master MND.io. Feel free to follow me all those places. I will tweet this stuff as well. I will put it on LinkedIn. I gotta get better at Instagram. I'm not a great Instagrammer, but I'll do my best. And the last thing is you can email me at academy@mastermind.io. We're actually going through and catching up on all those. It's something that I let slip because I got massive amounts of emails on there. I'm going to make that right. My wife and I are going to make that right. So my wife is also working with me now, which is great. Super duper helpful. So we're gonna make sure all that is caught up on and ready to go. So that's the last place for now. It's 4th on the list because it's going to be the slowest form of communication, but hopefully we can switch up this order in the coming weeks. All right. So here we go. Again, if you've been here for a while, most of today, and honestly only today, is going to be much of the same. After this, the course actually differs from what we've done quite a bit. Atoda, welcome. Good to see you. It's been so long. Super busy at the moment. I really appreciate you coming through. That means a lot to me. I definitely I'm going to reach out. I need to get up with you guys. It's really good to see you. Thanks for coming through. All right. So programming is hard. Let's start with that notion right now. Programming is difficult. All right. So I want it can be difficult, but it can be approachable if you have the right mindset. You got to have the right mindset if you want to get through it. You can do it 100%. I'm going to make sure throughout the process that I'm giving you all the good energy to make sure that you know you can do it, and to help motivate you and get you through the process. But here are the main takeaways that I want you to have for this. The primary ones are that I want you to have a strong understanding of programming and computer science concepts. That's the main piece. That's the topic of the course. So at the end, I want you to have a very strong understanding of programming and computer science concepts. That's point number one. You will know, I'll make sure that you understand these concepts, okay? Then I want you to understand how to use code to solve problems, because knowing the concepts is great, knowing the tools is great, but where you make the money is knowing how to use these things to solve real problems. And again, this has been taken from. I've done courses before. I've done syllabus days before. You will not be using Python in this course. You will be using GOLANG in this course. But so you'll be understanding Go and its uses. I'll update that. I'm not logged in right now. Actually, I am logged in, and so let me update that before we do this. Go and its uses. I want you to know how to use Go. I want you to know why to use Go. Yeah. So those are the primary things. Just because they're the primary, though, yes, it does mean that they're the most important things that you need to know right now. But it doesn't mean it's the only things I need you to know. And it doesn't mean it's going to be the things that make you most successful. These secondary things are super duper important to your long-term success. What's up, Mr. Demon Wolf? Amazing to see you. Been a while. But I want you to understand how to approach learning new concepts and technologies. So all of programming is difficult. Learning how to code is difficult because it's very abstract. You're taking a bunch of concepts, you're learning how to use a bunch of tools, and basically someone's teaching you how to use a screwdriver, how to use a hammer, how to use a nail gun, how to use some glue. They're telling you how to cut some boards with a saw. And then they're telling you to go build a house. That's what programming is. That's why it's so difficult. Yes, I can do all those things individually. I can understand those concepts individually. I can know how to use those tools. I know how to use a leveler, but that doesn't mean I know how to build a house. Maybe I can build a birdhouse. Maybe I can build, something smaller. But that's kind of what programming, the way programming feels, at least in my opinion, that's how it feels when you're learning. It's like, okay, I understand this one thing, but now you're telling me to go do this big thing. Doesn't really make any sense. And so I want you to learn how to learn here. We're gonna talk about those things. We're gonna talk about different methodologies for learning, but I want you to figure out in yourself how to approach new concepts and new technologies. You gotta become at peace being lost or confused, or lost and confused, because this is the norm. This is one of the few industries where you aren't supposed to just know how to fix it. That's just not how it works. You will be lost. You will be confused very, very often. And part of the fight here, part of the struggle is going to be your ability to be comfortable, to be at peace being lost. I'm lost every day. Been in the industry for a while, and I'm lost all the time. I'm uncomfortable all the time. You get good at it. Don't worry. I want you to realize that nobody knows it all. There are a few know-it-alls, people who make you feel like they know it all, but nobody knows it all. And it's not up to you to know it all either. You're going to focus on the things that you want to focus on. You're going to get a good base. You're going to get a good foundation and a number of things. But you're just going to know them. You're going to be familiar with those things, and you're going to get good at just a few things. And so what we're going to talk about later in the course, we're going to talk about the T-shaped developer, but think about the letter T. So you're going to have a broad level of knowledge in a lot of things. You're going to know a lot of things, just a little bit. And then there's going to be a few things that you dive deeper on. And so that's going to create that T shape. And, that's what's expected of you. You're going to have one or two things that you know really in depth, but have a little bit of knowledge about a lot of things. So you don't have to be great always. Yes, we'll talk about imposter syndrome as well. It's a real thing. 3 years of experience required for a tool that was released 2 years ago. Absolutely. We'll talk about how to go about that and how to approach that as well. I need you to have a strong belief that tech is for you and that you can thrive in it. This is the number one reason why I'm here. This is the number one reason why I stream at all. This is the number one reason why I do any of this, is because tech, if you want it to be, tech is for you and you can thrive in it. It is one of the most unique opportunities I feel like the human race has ever had at scale, to be able to create opportunity for yourself. Tech, like healthcare, is going to be an ever-growing field, and there just aren't enough people to support our technical needs. And you can find a place in it. Everybody It's not going to be, everyone's not going to work at Twitter. Everyone's not going to work at Facebook. Everyone's not going to be the most amazing developer in the world. But there's companies that who will pay you very well that just need some website updates. Okay. So there's also not just programming. There's a billion things you can do in tech. There's non-technical things you can do in technology, but I want you to understand that tech is for you. There's a space for you. And the first one might not be the fit, but it's up to you to find it, but you will find it. And then I want you to learn how to use memes correctly, because, it's the way that we speak. It's the way that, maybe it's just a millennial thing. That's what I've been told, that millennials overuse memes. It's how we express ourselves. But I want you to know how to use memes exceptionally. Yes, you're looking for a job. It's exhausting. Particularly the first job is absolutely exhausting. It's very tiring. It can be demoralizing. It is where most people, it's where a lot of people kind of fall out of the industry. Keep fighting. It should be your full-time job. Should be finding a job for that first one. Once you get the first one, I won't say it's gravy after that, but it does get much, much easier for you to make opportunities for yourself after the first role. What you have to understand about the tech industry, you got to understand that this is one of the few industries where people will pay you very large sums of money without any proof that you know the things that you're supposed to know. You're not taking the bar here. You're not passing med school here. You don't need a degree. You absolutely do not need a degree. If that's something you've been concerned about, well, we'll talk about that. I do not have a degree. I did go to school for a little while. I failed basically all the classes for programming, to be honest. But you got to think about that type of industry. You genuinely can go make $150,000, $200,000 a year with no degree, with no real credentials, besides having messed around with this stuff, having done these things, having learned these skills. And so that does make the job hunt a little bit harder than other high paying industries where there are rules that make you qualified for a role or not. It's all about you being able to prove that you are sufficient for these roles, and it can be tough. It can be really tough to figure out how to do it properly, but once you figure it out, again, it can be life-changing. It can be tons of job security, tons of job mobility, tons of income mobility. There's a lot of upsides to it. Thank you so much, Varithian, for the tier 1 sub. Good to have you. Good to be here. All right, next slide. So you see what you expect to see, Severus. This is a Harry Potter quote. And so this is just about the expectations here, what I expect to see. Active engagement, please be actively engaged if you want to get the most out of it. I actually don't, I know this sounds bad, I don't care if you're actively engaged or not. This isn't about me. This is about you and your experience here. Active engagement. This is just, say hi. If you're gonna be here, say hi to people. Get to know somebody in the stream. Say hello specifically. Trash Dev, what's good? Good to see you. Thanks for coming through. Trash Dev is also a great streamer. If you want to follow someone, learn a little bit from someone, learn a lot from someone actually. Definitely follow Trash Dev. I'll give you a shout out in a second. But active engagement, just speak to people, say hello, say what's up. Hop in the Discord, talk to somebody. The more engaged you are, the more likely you'll be to make it to the end, to make it through the entire process. Ask questions. Do not be afraid to ask questions. There are going to be times when I'm going to be setting you up to ask questions where you won't be able to get past where we're at unless someone asks the question. Ask questions. Do not be afraid. No question is dumb. No question is stupid. If you don't know the answer, ask. Again, make sure if it doesn't get answered in chat, ask in Discord, ask wherever. Find a space to ask questions. There are a couple of other asynchronous places we'll talk about where to get answers from. Do not let a question go. Again, even if we don't answer it real time, write it down. Make sure it gets answered. Ask it next stream. Ask it in Discord. Send a message to me directly. Make sure you're getting your questions answered. Ask whatever you need. Answer questions. If you think you know the answer, Answer the question. Don't be afraid to look dumb. It's okay if you're not 100% sure. Say, hey, I'm not 100% sure, but I think it's this. If you think you might know the answer, try to answer questions as well. It will it'll help. It'll cement your learning. It'll also make you feel more confident in yourself. But feel free to answer questions. Check out all the supplied resources each week. You're going to get in the Google Classroom. After each class, you will actually get some learning resources. And this time, because we're only once a week, you will get assigned resources. You will get one, like, I don't want to call them projects, and I also don't want to call them homework assignments, but you'll get a hands-on resource that you should do. It might be a tutorial, it might be, actual problem to solve, but you will get a hands-on thing to do each week. Feel free if you want to do it in a group. Absolutely, I love it. No need to do this alone. You never need to do this alone. Lean on each other for help. In the real world, you're going to be working collaboratively with people, so it's okay to ask for questions. Don't ask for answers. Don't ask someone to just give you the answer to a problem. Have people help you work through it. But yeah, so just go through the supplied resources and work through whatever problems are given to you. I want you to spend at least 5 hours per week learning outside of the boot camp. Okay, I would like you to. This is at your discretion, but I would like you to spend 5 hours outside of the material that I give you. Because I'm not going to give you 10 hours of material. You all have lives, but I'll give you paths to go down. And I'll also give you optional readings as well. Optional readings, optional things to dive into. And I'll give you places to go practice. I'll give you things to go practice. And so if you want to get the most, I would say spend at least 5 hours outside of this class, learning a little bit more. Do we go over this in class later on? What I'm going to try to do is a bi-weekly, and so the only reason I haven't announced this because I don't know if I'm trying to make it work with my schedule. I'm going to try to do a bi-weekly, like a office hours stream that will also get posted. So even if you can't come to the stream on like a Friday, for each stream where I go through the past 2 weeks problems, I will post answers to problems. I will post solutions. The thing about programming though is it's going to get hard for you to not compare your answers to other people's answers. And like, there'll be times where you're right and someone did something differently and now you feel like you did everything wrong. And it kind of creates this weird disbelief in yourself or mistrust in yourself, because you don't know any better. And so I'm going to try to figure out a good way to do that. The goal is going to be to do a bi-weekly stream for us to actually work through those problems. All right. That's what I expect to see. Go be great. Affirmations of progress. Feel free to do that. Let people know what you're doing. Let people know what you're working on. Be vocal about your journey. I'm telling you, I know this is probably a little bit cliche at this point, but start, if you're serious about this, go on your LinkedIn, let people know. And it's not even necessarily about promoting Mastermind. It's about letting people know what you're doing. People are watching. People are around to help. Like let people see what you're doing. People will take notice. People will join in. People will provide support. People will help you. And so let people know that you're learning. Let people know that you're trying to be great in this area. All right, let's go through the curriculum. So I'm Zatcher just said imposter syndrome. A couple people have alluded to imposter syndrome. It is something I want to talk about, but actually I think this is a good time to talk about it. All right, as we dive, we're gonna go through the curriculum, but as we dive, we're actually gonna learn some things tonight, and you might feel this way. You might already start to feel weird about what's going on, and some of the stuff might already seem confusing to you. Day one. Imposter syndrome. If you don't know what it is simply it happens to most people, especially in high skill fields, where you feel like an imposter, where you feel like you aren't good enough to participate as everyone else is participating. You feel like you got lucky. You feel like you were given the role where you are when you're not ready, and it can cause very serious mental problems with being able to work through the jobs, to just exist in a role. It's very, it can be debilitating. It can really beat you down. It can really push you into burnout and make this career tough. Yes, people talk about all the cushy parts of the tech industry, of the you get flexible lifestyle and cool things like that. But yeah, this stuff can beat you down. This stuff can make you feel really bad about yourself. But it doesn't have to. And there are things that you can do to recognize what's happening and to avoid it. So this right here, this is called the Dunningkruger effect. And I'm about to share it right now in Slack. And I will put it in the Google Classroom as well. Actually, I'm gonna share it in the chat right now. Let's see. Let's share this here. So feel free to click on that. But what this is an effect that causes you to, this leads to imposter syndrome. And so what this is, it's a graph. It's a graph that corresponds to your confidence in something and your competence in something. So right here on the left axis over here, it's about your confidence. So you can see here that when you start something, your confidence is, you're first learning about it, your confidence shoots way up very fast. Look at your competence. You're not very competent in it, but as you start to learn something new, you are literally going from 0 to 100. If I teach you one thing about programming, you now literally know, well, maybe not literally, but the amount that you know is 100% or even more than you knew before. If you knew nothing and now I taught you something, you know way more than you knew before. And so what happens is your confidence shoots way up because you don't really know all there is to know yet, okay? And so what happens is you feel really great. You say, I can do this. I know this stuff. I'm very smart. And then as you start to learn more, as you start to become more competent, as you're actually getting better at it, you start to also realize how bad you are at it, because now you know there's all this stuff over here that you don't know. And actually, I forgot I have this little, I forgot I can now draw on the screen. But yeah, you get up here and you feel like you're so good and you're so great. But as you learn more, as you're starting to get better, you realize how much you don't know, and your competence becomes average. This is where you're average. Look at this. This is average competence. This is where your confidence is the lowest. Okay? This is where you fall off the, what do they call it? They call this Mount Stupid or Mount Dum Dum or something. They're like this is where you think you're great and you fall off of Mount Stupid and you go into the trough of despair or the valley of despair, where you feel like you know nothing, but you know a lot. Look, you've learned all of this. You've learned all of that, but you're that competent, but you know how much there is that you don't know, and so you feel worse and worse about yourself. And as you become more competent, as you start to move towards expertise, your confidence begins to go up. All right? This is the Dunningkruger effect. This is something that happens all the time. It'll happen to you multiple times with different topics, with different things. Here's what I want you to do about it. I want you to be careful when you're up here. When you're up here and you're like, I'm so great, take a step back. Take a step back. Take a step back off this ledge. Okay, you're gonna be on this little ledge right here. Take a step back and realize that there's a lot more to go and that it's good. Celebrate what you know. Take a step back and realize there's a lot more to learn, and don't let yourself get this high. Never let yourself get this high. Stop your confidence somewhere down here so that you won't fall as far or you won't fall at all. And so just temper that. Okay, know that there's a whole lot and there's a lot to learn and there's a lot to master. Also, realize that it's okay. Remember, I said no one knows everything. Most people know nothing. Most people know nothing about these things. When you're done with the class today, you will be more competent at programming than 90% of the people on earth. Okay, you will be in the top 10% of people on earth in terms of programming, because you will now have that much more information than they do. And as each week you'll learn a little bit more and you'll move up in those ranks. But you'll get to a point where you're valuable. Okay, you'll get to a point where your knowledge is of value to somebody, some company, and you'll be great. So we'll get there. Conquesting, I'm about to give you the syllabus right now. The trees, but not the forest. 100%. Take a look. Thank you so much. Call TwitchBot. Thank you. Is that Coil TwitchBot? It's blue on my screen. Really dark. Can't see it. Thank you so much for the bits. Yes, this is knowing enough to be dangerous is really kind of the worst part. But yeah. All right, so here's what we're gonna do. Let me get you to the actual curriculum. So the curriculum, let me make let me pull that up. The Notion page, I think the curriculum is at class.mastermind.io. Let's go there first. And Basecamp, camp code. Here we go. So I'll share this with you. And I'll make a command for it. Commands, edit. What's this? This is the syllabus. Yeah. It's kind of a syllabus, not really. Well, now you can do exclamation point syllabus and get this. And so this is what we'll be focusing on over the next 22 weeks. And so, again, if you know some of these things, that's completely okay. You don't have to come through each class. We are going to be focusing on the concepts. We're going to be focusing conceptually on these things. And again, we're using the Go programming language, but that's okay. You will be able to, if you understand these things conceptually, you'll be able to move to other languages at your leisure, your leisure, whichever one of those it is. And we'll talk about why we're doing Go in just a few. But today we're going to be doing the intro to programming, going over just what to expect in the class, but we'll actually go dive into to programming, to the basics of programming and computer science and all those things. Next class is when we'll get all of our environment set up. We'll get all the tools that we need installed. We'll get everything going. Oh, actually, command does not exist. I messed up the command, so syllabus won't work. Hold on. Commands, add. It doesn't actually exist. Syllabus. There you go. Now it'll work. Then we'll dive into the command line. So we're gonna need to learn a little bit about dealing with our computer through a programmatic interface rather than clicking around in the graphical user interface. So we'll spend a little bit of time learning that. So we're not going to be learning Linux here. You'll learn some Linux commands, but this is going to be more about navigation. If you do want to learn Linux, which I think is incredibly important, literally the first section of the DevOps series that we're running is a 7-part Linux course. So if you want to start doing that on Thursday, I highly recommend that you come through to learn Linux over the next 7 weeks. It will make you a better programmer. It'll make things a lot easier for you. Then we'll dive into actually running code and talking about data types and displaying output. We'll dive into strings, parsing strings, and then numbers, and then collections, things like arrays and slices. Then we'll start to learn about logic. So you'll be programming next week. You'll be writing some things in a text editor, but you'll be programming each of these weeks. And then we'll get into more logic-based things. We'll learn how to control the flow of our applications, dive into loops and functions, and learn how to package things together nicely, working with errors. And then we'll learn some memory management stuff. We'll learn about pointers as well. Go, you don't have to do. Go has something called garbage collection. We'll talk about that, so we don't have to do anything with memory, but we'll learn about pointers and what that means and the value there. Then we'll start to dive into what people think about when they think about software engineering, and we'll dive into the structs and the algorithms and the data structures, and we'll learn how to use those things effectively, and we'll practice, and we'll learn common algorithms, we'll learn common data structures, we'll learn how to use these things to solve problems, then we'll learn how to solve problems, and then that's when we'll move on to the next phase. So the next phase is called a trek. So we'll move on from base camp, and then we're going to actually trek up the mountain after that. So over the 22 weeks, you're going to learn, again, the foundational things. You will learn how to solve problems. You will know how to code. You'll know how to code here. What you won't do, though, is you won't be building any products. We'll be solving problems. We'll build some tools, but we're not going to build a product. This is not a web development course. You will be able to learn how to do web development after this course much faster, much easier. Those programming concepts still apply, but we're going to be learning core, fundamental computer science and programming concepts. Any questions about that? Does anyone have any questions about any of the weeks? Anyone have any questions about something that we may or may not be learning? Let me know now. Also, we're drinking bubbly right now instead of, we're not drinking LaCroix because the place that I'm in right now has switched over to bubbly instead of LaCroix. And it's good, you know, it's fine. LaCroix never came through with that sponsorship like we wanted, but it's all good. Oh, yep. Estimated time for each session, between 2 and 3 hours. So 2.5 hours is the is what I'm going to aim for. Some sessions will be 2 hours. Some will be closer to 3. I'll make sure none of them go over 3. Anything about containers? Not in this course. The Thursday course, which is a DevOps anthology, later in the course, we will be learning all about containers. Let's see, that one's called an anthology series, and so these are the things that we're going to be diving into in that series. So this is like the more DevOps, SRE, systems admin side of things. So we're going to learn Linux first, then like server stuff. Then we'll learn a little bit of Python actually. Then we'll do a bunch of Git. We'll actually learn Git here as well. Networking, monitoring, and observability. Then here's where we'll dive into Docker. It'll be a while. This is many weeks away before we dive into any containerized stuff. We'll be learning some Terraform and some Kubernetes stuff there as well. Let's see. Will this help you get into the cybersecurity field? Yes, in that it's going to be a tool that you can use in the cybersecurity field. Cybersecurity has its own collection of things that might help. This one, the cloud one, so tomorrow's bootcamp might be more beneficial for you getting into the cloud industry. Tomorrow's, maybe Thursdays, might be a little bit more beneficial than this one, but it won't hurt you at all. Yeah, obsessed with LaCroix. The whole sparkling water thing, I thought it was a joke. Now I'm obsessed as well. It's better than being obsessed with soda, I guess. New season, new sponsors. Yes. Yes. We actually have some sponsored things happening. We have some sponsored things happening. There will be, pretty consistently, there will be jobs passed along to you. So expect to see those starting next session. And apply to them. Don't be afraid to apply to them. Even when you're not ready, start applying, start making connections with these companies. Let's see. Is it advisable to attend all 3 camps? If you have enough time, yeah. If you have enough time, here's what my advice would be. If you are just starting out, if you are completely new to all this stuff, I would not attend the Thursday camp. I would attend today's and tomorrow's, the Mondays and the Tuesdays. The Camp Code, Camp Cloud is what I would attend. Both of them are very, I think, beneficial to helping you do whatever you want to do in tech. I think they're valuable. If you have the time though, and you're not completely a complete beginner, feel free to attend all 3. There's going to be some overlap between the third, the one that's on Thursdays, and these, but yeah. Go programming is sought after in cybersecurity. Yeah. Popular for malware because they run everywhere as binaries. We'll talk about what that means. All right. A register for all 3. Yeah, completely okay. You can sign up for the registration is just so I can have an estimate about how many people are coming, and so I can figure out what I can provide, all those things. You're new to all of it, Eggman? All good. We're starting from the very beginning. Okay. So that's the curriculum. You can get to it. Now that we've talked through all of that crap, all the boringness, we're gonna get started. So I'm gonna give you 30 seconds, a minute, go get some more water, go to the bathroom, go to the restroom, go do what you need to do. And then we're gonna get started. We're gonna dive right into it. We're gonna start learning about programming right now. Okay. So I highly advise you to take notes. I highly advise you to do whatever you need to do. If you need to watch this back, if you need to write down, what time it is, so you know how long into the video it is, if you want to go back and watch it later, whatever you need to do. Again, I think notes is very, very helpful. If you can write your notes, I think that is more valuable than typing your notes, but typing notes works well. If that works for you, great. But writing really, really does help. Yes, take a little bit, because we're about to get started. Our Linux runs the world, so I might show up. Yes, Linux 100% runs the world. Uh, people who are unfamiliar with it are always floored by how much so. But yes, Linux absolutely runs the world. I would say if you all have the time to take the 7-part series, as much of the 7-part series as you can. So the Thursday one for this first section of the Thursday class, I would recommend if you have the time. Do treks start right after base camp? Yes, they do. We will go directly into the treks after base camp. We will also start a trek mid base camp. So we're actually gonna start a trek for a different topic, so that people can so we can start to offset things a little bit. We will start a new trek in the probably week 10 or so. We will start up our first trek, so that we can start to have some beginner level things and some intermediate level things running at the same time, and eventually we'll get to a space where we have a good mix of things. Go here though. You can share your link to register. That went nowhere for me. Linux is my friend. Linux is great. You can get a job just learning Linux. And Linux is one of those things. So out of the 3 classes, this is going to be the one, again, that's going to make you feel, it's going to be the hardest to wrap your head around things. I think programming is so interesting because the amount of concepts to learn, I think in comparison to other technical disciplines, is relatively small in comparison, because you're not expected, programming, you are expected to know things conceptually, but it's not really about memorizing. You don't have to memorize tools and how they work. You kind of learn the ethos of things. You kind of learn the structure of things. You learn conceptually how things work, and then you apply that knowledge. Whereas some other things, like when you learn Linux, you've got to memorize commands. It's just how it is. Yes, there's some conceptual understanding of that, but some of it is rogue memorization. And when I do this thing will happen. And programming isn't necessarily that same way. And so it's going to be the one that's going to make you feel, has the potential to make you feel the worst, for sure. I left Linux over Mac, but Linux never left me. Still running the same dev environment. Yeah. We can talk about operating systems all day. You can see here that I'm running Windows, and you might say, that's weird. I don't see any programmers running Windows. This is purely, I use the tool for the job that's going to work. I wanted to run Linux on this. I had Linux installed on this, actually. So I do have a dual PC setup. My main PC runs Windows because I needed to run Windows for some work things, for some specific pieces of software, including the things that I used to stream. This laptop, actually, if you all have never heard of, there's a company called Framework. And this is a Framework laptop. It is actually a fully repairable, fully upgradable laptop. It's pretty darn dope. It's actually shipped to you as a bare bones laptop, and you can put it together yourself. If you're not familiar with it, check them out. I think their website is frame.work. I think that's the actual domain. Yes, shout out to Linus. I love Linus Tech Tips. He invested in it. It's pretty cool. This laptop is pretty darn impressive. I really like it. I like it a lot. And I do. If you're looking for a laptop, I recommend you checking out. But when I was using Linux, there were issues with the graphics drivers and the capture card, and I actually couldn't get a match on the screen resolution. This has a unique aspect ratio. This is not a 16:9. This is actually more of a square. It's a 4:3 or 3:2 aspect ratio, and it caused a bunch of issues when trying to put together the stream. I don't have time to deal with that, so we just put Windows on there. Yeah, and so that's that. We are where we are. Mr. Griffin, thank you for coming through. Shout out to Mr. CM Griffin. It's good to see you, my friends that I haven't gotten to speak to in so long. Let me give you a shout out. If you're not following Mr. CM Griffin, first off, the guy's an animal. He can stream for literal, many, many hours. Sometimes I'll catch him. Same thing with Callow. 7, 8, 9 hour streams, programming, building cool apps. A great channel to follow if you're trying to see how this stuff is actually implemented. He builds real things on his channel. Pretty dope to just hang out with. Really cool guy. Thank you for coming through. All of the amazing folks from your channel, come on in, come get comfortable. You're here on the very first day of our new boot camp. We're going to be spending 22 weeks learning how to code in Go. So if you want to learn core computer science concepts, if you want to learn how to use Go, this is the place. Tuesdays we'll be doing Camp Cloud, so we'll be learning how to do cloud computing with AWS. And on Thursdays we'll be doing a DevOps anthology series, so we'll run through all the DevOps stuff, Linux, some cloud computing stuff, infrastructure as code stuff with Terraform. Teach you some Git workflows. We'll teach you all CI/CD, all that stuff. We'll be learning there. So thanks so much for coming through. Okay, let me give Callow a shout out as well. But thank you so much for coming through, Raiders. Come on, get comfortable. I hope you want to learn with us. But yeah, Microsoft claims they run the largest cloud in the world. I think people are surprised how much of the world is running on Windows. Yes, that is true. Microsoft, a lot of the world, 100% is running on Windows, especially desktop stuff. Microsoft, I 100% believe they have the largest cloud in the world. AWS has the largest market share, but I fully believe that Microsoft has the largest, sheer largest cloud ever, because they're Microsoft. I'm actually a big fan of Microsoft. I've changed my tune in the past few years. I'm actually a pretty big fan of Microsoft and Microsoft products. I use a Surface Laptop Studio. I never thought I would be doing any of that as a Linux guy, but yeah, it's they're pretty cool. But the reason why we're using Windows is simply because it will serve its purpose, and for the streaming purposes, it's less things I have to fight with. Plain and simple, it's less things I have to fight with. So we'll be using Linux on Windows though. Like, we're gonna be using Linux on here, and so that's something that Microsoft has. If y'all didn't know, ships with a Linux kernel now that you can download and set it up and do some cool stuff. So yeah, no, I agree. It's pretty dope. Microsoft has changed a ton. So it doesn't matter what kind of computer you have. I'll give you options for everything. The more that you come here, the more you can put off reading docs. Yes, a little bit. All right, so let's get started, because we have a number of things to talk through, and I know you all want to learn how to do these amazing things. Let's get started. What in the world is computer science? Well, it is simply the study. That's what science is. It's the study of computers and computational systems. Systems being the way things work. Unlike electrical and computer engineers, computer scientists deal mostly with software. Okay, software is it's the code. It's the applications that are made. And software systems. So rather than dealing with the hardware, computer science is more about the software, not the hardware. We will learn a little bit about the hardware in a second. The theory, the design, and the development and application of those things. So that's all computer science is. We'll be learning the theory about software and how to build it, and how to go about it, and things you should do, things you shouldn't do, how the computer systems themselves work, how things happen. So what the heck is programming? That's computer science. What in the world is programming really? Well, programming is simply providing a computer or a machine with coded instructions for the automatic performance of a task. So I'm going to provide the system a coded set of instructions, and the computer is going to read that and perform the task that it was instructed to do within that code. So we are just programming. Coding is just us telling the computer what to do, how to do it, what order to do it, when to do it. That's what we're doing with programming. We are literally we're telling the computer exactly what to do. We're controlling the computer. But how do we give it instructions? How do you take it? How do you give the computer actual instructions? And you do it through a programming language. Okay, so the programming language that we're going to be focusing on in this class is Go. But there's tons of other programming languages. There's PHP, there's Java. Somebody might yell at me if I say HTML is a programming language, but in the picture they put it there. There's C#, there's Groovy, there's Dart, there's so many different programming languages. And really, these are just different interfaces for us to be able to speak to the computer. They're all built to be able to allow us to tell the computer what to do. Yes, Ruby on Rails framework. Ruby is the programming language. There's tons of programming languages out there to choose from. How does the computer understand the instructions that we give it? So we're going to give the computer instructions using a programming language, but how does it understand those things? Well, it starts with source code. The first part, source code. And so this is where you should start taking some notes. Source code. This is going to be the human readable code that we are going to be writing. This is what you write. This is what, when someone says they're a programmer, when you think about programming, coding, this is the part that you're thinking about. Writing the source code that the computer is going to eventually understand. So source code is the human readable code that you write. And when we say human readable, if you look over here, while you might not really understand the things that are going on here, it has words that you can understand. Words like range, print, and then it's got some some comments here. Normal English words: for, print, if, else, print. You can read this. You might not know what it means, but you can read it. You can look at it. You can identify the characters. This is something that you are familiar with. Okay. Source code, the human readable code that you write. It is going to be the source of the application. This is where you create these things. After the source code, so you take that source code. And so when we say write source code, you're writing a file. It's going to be in a file just like your Google Doc, your Microsoft Word document that you write, that book report that you just typed information into a file. Your source code is you typing text. It is text, and you're typing text into a file. So you're doing almost the exact same thing. So it's not some kind of special operation that you're doing when you're writing code. You are writing text into a file, just like if you were building a book report in a Word document. From there, a couple of different things can happen. Okay, so how does the computer understand our source code? How does it get from source code to something that the computer understands? We're going to talk about this in a few minutes. The computer understands something completely different. It doesn't really understand that programming language. Computers understand. People are going to say ones and zeros, but it understands two states: ones and zeros. Ons are off, yeses or nos. It's digital, okay? And it understands binary. It understands those two different states. And so eventually we've got to get some things basically from the source code down to those ones and zeros so the computer knows what to do. The way that that's done is through compilation. It's really compilation or interpretation. And I'm saying this just because this is going to be a major point that we're going to have to spend some time on. So compilation versus interpretation. What is a compiler? A compiler is it's a pretty complicated piece of technology that translates source code into machine code, binary, or byte code. So you don't need to know what any of those are right now. What you need to know is that a compiler takes the source code that you or I write, and it translates it into some type of format that is more readable or completely readable by your computer. All right, and so it takes it, runs it through it, and it takes an input and it gives you a completely different output that the computer reads. Once you compile an application, once you take the source code that you write and you compile it into what the computer can read, now you won't be able to read it anymore. If you were to look at the actual thing that the computer reads, you won't know what you're looking at. It'll be symbols, it'll be ones and zeros, it'll be all kinds of stuff that you can't make any use of. But that's what a compiler does. So there are essentially two kinds. Really, there are kind of four kinds, but there are two kinds of programming languages. One is compiled. So there are some languages that take the source code and compile it all into something that the computer reads before you can use it. So the computer can't run the application if the language is compiled. If it uses a compiler, the computer can't run the code until you got to write the code. Then you have to do the full translation. And once you translate it all, then the computer can run the code. The other option here is an interpreter or interpreted languages. Some languages, on the other hand, are interpreted. This is where it's going to go line by line and interpret every every time it gets to a new piece of code, it's going to basically take that and it's going to translate it into something like the computer can use. Okay, so over here on the left, let's see, this is where our source code is. All right, and it's going to go down line by line, and it's going to start to interpret what we mean here. And the interpreter is going to take the instructions and it's going to simply translate it into the stuff over here. What this means though is an interpreter, the whole application before you can run it doesn't need to be translated into machine code. You can make changes and you can immediately run the application and it will begin to attempt to translate this into something the computer can do, and it'll start to actually take action on those things. So compilation, we're going to take the source code and we're going to translate the entire thing right up front, and the computer will run whatever the output is. An interpreter or an interpreted language, we will take the source code and it will begin to interpret it line by line. We will 100% get deeper into this. This is a very high level overview of an interpreter versus a compiler, but we will get back into it. Cook the Ryan, good to see you. Thanks for coming on through. Thanks for the Twitch Prime sub. Appreciate you. Yep, I'm glad to be back. Very, very glad to be back. So bytecode. There's a little bit extra on here. So there are some languages that do this in 2 steps, actually. So Java is one of them. .NET is another one. Rather than going straight from source code and compiling down to machine readable code, bytecode is an intermediary format. Okay, so instead of going from 1 all the way down, it will go from source code into this intermediate. It'll get translated into this intermediary format that has been optimized to be interpreted quickly. So Java, when you run Java applications, they run on something called the JVM, the Java Virtual Machine. And so there's a tool that's literally been built to be able to interpret Java code very quickly. And so there's some benefits to this. There's some the pros to this, some cons to this. We will learn about the pros and cons. But right now, I want you to know that there's compiled languages, ones that need to be fully translated before they can be run. There's interpreted languages that will get run line by line, and each line will get translated one by one. And that there are languages with bytecode that kind of combine these, and they compile basically some of the code down into bytecode, which is not fully machine readable code, but it's where this little virtual machine begins to interpret that code very, very quickly. It can be a little bit complicated. It's okay if that part's confusing, completely okay. I don't want you to worry about that right now. I want to deliver it to you right now, and then I'm going to help give you some of the resources to help you distinguish between them later. What's up, Steez? Good to see you. Speaking of languages, is there an accent from Baltimore, DC area? Just curious. It depends on who you ask. I think I'm from closer to DC. I'm from Prince George's County, right outside. I think people from Baltimore have a pretty strong accent. I do think people from DC have an accent as well. I don't think it's as strong, but there's definitely an accent there, 100%, definitely. People I've been in Baltimore for almost 10 years. The Baltimore accent still, to me, it sounds so strong still to me. It's pretty wild. You from Baltimore now? What's up? Oh, what's up, Charmaine? Good to see you, Ismainzy. I am not from Baltimore. I'm from the county now, okay? I'm from the county now. I moved out of the city, okay? Yeah, Aaron earned the iron earn. That's true. Aaron did earn an iron earn, 100%. But nah, it's, definitely an accent for sure. So if you hear an accent from me, I talk quickly. I got a deep voice. I probably have 2 or 3 accents at this point, all merged together. We all got them. I live in College Park, Greenbelt, Laurel, Columbia. Yeah, there's definitely a difference. 100%. Okay. Machine code. When we talk about machine code, we're talking about binary. And this might be a good, we'll wait. So binary, bi. The prefix bi means 2. Okay? People will tell you binary means 1s and 0s. That is how we generally represent them. Ones and zeros is how we, represent the two states. But it's not ones and zeros. Your computer does not read ones and zeros. Your computer reads two states. It really reads on or off, yes or no. There are little gates in your computer's processor that basically either have electricity running through them or they don't. And that's the yes or no. That's the on or off, and that helps us mean certain things. So computers, that's what they read. They read ones and zeros, and we'll talk today. Before you leave, you'll understand how computers are able to use that to make some things happen. Yes, logic gate. Yes, kind of. We're gonna get real deep on that, but yes, logic gates. Transistors, really, yes. And modern processors are pretty darn wild. They're pretty interesting. We have a little part in here about CPUs, and we'll talk a little bit more deeper about how that happens. But just to give you a little precursor, your computer has a clock speed. So you might say, "Ooh, my i5 has it has a clock speed of 3.2 gigahertz, and it can turbo boost up to 4.1 gigahertz." And people throw out those numbers, but those gigahertz, those are essentially 1 billion transactions basically a second. Okay, 1 billion operations per second. So when it says 4.2 gigahertz is 4.2 billion operations per second that can happen. And so you can see how these numbers start to really matter, because we're talking about billions of things happening in a second. And so yeah, it's pretty wild how computers work. That also is how, ones and zeros, you got to be able to do a lot of them if you want to be able to make some things happen. But yeah. But compiled applications, compiled programming languages, compilation versus interpretation. Here are some of the differences here that I want you to know. Compiled, if we're taking the source code and we are translating it all right up front, what does that mean? Well, it means that the application is going to be very efficient at runtime. Very efficient at runtime. What do you think runtime means? Well, I'll help you out. Runtime means when you actually go to run the application. So when I actually am going to run the application, it's going to be much more efficient and very fast, because all of the translation has already happened. We're not doing it line by line. We are doing it right up front. So when we go to run it, it is very, very fast. It's very efficient. All the translation has already occurred. That automatically means that it doesn't mean that interpreted is going to be slow, but it does mean that interpreted languages are less efficient. Okay, so if compiled languages are more efficient, these are obviously going to be less efficient over here. Silly errors are caught at compile time. What this means is that if you did something wrong, if you didn't follow the rules of a programming language, if you did things incorrectly, when you go to compile your source code, it's going to fail, and you can catch bugs, you can catch errors before this application ever actually gets run. Because it's doing the translation, if it can't do the proper translation, it's going to run into an error, and it's going to let you know that it ran into an error. And so silly bugs, silly issues, silly syntax problems, they'll be caught during compile time. And this is some people like it, some people hate it, but it means that you won't, you'll catch problems before you actually run your code, which is actually good for like companies and people who are making money using their code. You want to catch errors as early as possible. Due to the efficiency of the program, compiled languages tend to be less of a strain on computing resources. More efficient, that means the resources that you need can be less. We'll talk about computer resources and what those are. That's your processor, that's your memory. So generally, this is a in general thing. A compiled language is going to be more efficient on your computer and use less resources. And then static typing. We are going to talk about static typing. This is not keyboard typing. This has to do with data. Static meaning things don't or can't change. They stay the same. Stays the same. So when we say static typing, this is talking about the types of data. We're going to dive into this in just a little bit. Gravity Wolf, not amused. Thank you so much for the tier 1 sub. Good to have you. All right. So interpreted languages, on the other hand, yes, they are less efficient. But what that means is code changes can be made and tested quickly. Why is that? Well, if we don't have to compile it first, if we don't have to, so compiled program, imagine this, you're writing a program, you run into a problem, or you just need to make a change. You need to go make a change to the program. Compiled language, you have to go change your source code. Then I have to take a step and compile it. And that might take some time. Now, computers are very fast. So the things that we're going to be doing are going to compile in no time, like almost instantly. But if you have a large application, it might take minutes. It might take 10 minutes to compile your application. And so, if you don't have to do that, you save some time. So I would have to compile it. Then I could run it and test it. And if my changes didn't work, I have to make another change, compile it again, and test my changes again. Interpreted languages, on the other hand, you can immediately go make your changes directly to the source code. And then when I run it, it'll attempt to run and it'll get down to where there's a problem. And if it's fixed, it's fixed. If it's not, it'll give me another error. And I can immediately go back in and make my change and immediately run my code. I don't have to wait for the application to get translated. It happens real time. But yeah, it is less efficient on the computer. This generally makes debugging easier. Okay, debugging just means finding bugs and removing them. So finding issues with your code. If you're looking for issues with your code, typically interpreted languages are easier to find, to debug, to figure out where the errors are happening, because you can almost let it run through to the line that you're having problems with, and you can track it a little bit easier because you can make changes quicker, and you can make things happen a little bit faster. And these have dynamic types. Okay, so dynamic typing. This means things change. Dynamic means things change. Static means they stay the same. And again, we're talking about data here. And this is going to be a very, very important part of what we learned today. We're going to make it make sense very soon. So in the industry, I appreciate your time taking to spread the knowledge. Absolutely. I appreciate it. Thank you for the kind words. It does help me keep going. But yeah, honestly, people always ask me why I do this. The only reason I do it is because I have been tech has been amazing. The tech industry has been amazing for me and my family, and I've had opportunities I never thought I would have. And my only goal is to help people see that there's a space for them, that they can do it too. I want you all to be able to be great. Be great. So thank you. I really appreciate those kind words. Oh no, time reveal. I won't tell Leon, but I appreciate it. But it's not a competition. Go learn from Leon. Leon's amazing. Go learn from anybody. I don't expect you to learn only from me. I probably should have talked about this in the beginning. I don't expect you to learn only from me. I want you to learn from whatever resources you need. I want you to watch us talk about stuff. I want you to go watch 10 videos on compiled languages after this and learn from a million people. There's, some of you aren't going to learn from me well. That's fine. Some of you are going to think I'm the best teacher in the world. That's great too. My feelings aren't going to be hurt. If you find a better speaker, if you find resources that are valuable for you, share them here. It's fine. Share them here, give them to each other, show people what helped you learn or help submit a concept for you. Completely okay. What's up, Lokoba? Thank you, Muon Gluon. Thank you for the tier 1 sub. All right, so let's keep it going. Compile versus interpret is dope. So we're gonna talk about static versus dynamic, I think, next. Oh, actually, I need to hit the button, then this button, then this. Y'all know I'm new to this. I'm not new to this, but I'm new to this. I'm using a Wacom tablet. Wacom. I'm using a Wacom tablet. Last time we were doing the class, I was actually using a Microsoft Surface Pro. I broke it. That's why we're not using it now. I actually do like this, the Wacom tablet. I just don't really know what I'm doing. It's a little bit hard. It's a little bit harder for me to use than the Surface, but I think we're doing okay now. Cool. There we go. All right. So data types. we're going to spend lots of time learning data types, but specifically what we just talked about here, we talked about dynamic typing and static typing. This is what we're talking about. We're talking about these data types. And so in programming, everything's data. Like all you can do with code is deal with data. That's all you're doing. You're not doing anything else. You are taking in data, manipulating data, pushing out data. You're taking input, doing some work processing, providing output. That is literally what you're doing in 98% of programming things. Taking in data, manipulating that data, providing some type of output based on what you took in. Data types are different types of data. So there are things called strings. Strings are words and phrases. Think about words and phrases. They're a list of characters. They're almost always in double quotes. And so that is a very specific type of data. It's called a string because it's a string of individual characters. Characters are a data type. In some languages, they're called characters. Some languages, there's runes. In Go, there's a couple different ways you can handle characters, actually, but it's a special type of data. The reason why the type of data matters is because the way that programming languages are built, it will affect what you can do to it. So when you have a string, when you have a word or a phrase, there are certain things that are built in that you can do with that string, okay? Things like finding out how long it is, things like grabbing an individual letter, things like uppercasing it or lowercasing it, stuff like that. And so the pieces of data matter. Then there's integers. So these are numbers. So we have strings, which are words and phrases, letters. We have integers, which are whole numbers. We have floats. So an integer is a different piece of data from a float. So floats have decimal points, and so you have two numbers, and in some languages those two things can interact. In some languages those actually can't interact, and there's different things that you can do with floats that you can't do with integers and things like that. Booleans, true or false values. This is a whole type of data in programming languages. Very, very important. True or false value, literally true or false. That's what a Boolean data type is. Arrays and slices. These are built-in primitive data structures. They're collections. So an array is basically a collection of other types of data. So I can have a collection of a bunch of strings. So maybe I have the word hello, maybe I have the word goodbye, maybe I have the word what's up, maybe I have another word, and I can have them in a collection where they're all part of a data type, but there's individual pieces of data in there. Or I could have an array or a slice with the integer 1, 2, 3, 4, 5. And so I could have a collection of things. We're going to spend time talking about this data. I don't expect you to know anything about this types of data, but what I want you to know is this is what we're talking about when we talk about types. Static typing, dynamic typing. We're talking about this types of data. What this means is that in compiled languages, the type of data, it doesn't change. You specify it, you set it, and once the type of data is set, it can't change. It stays the same throughout your program. In interpreted languages, this means that the types of data that things are, it can change. It can change throughout the application. And also that interpreted languages generally, in languages that are dynamic, generally will try to force the data to work together or play together nicely. Compiled languages don't care. If they're not supposed to play together, it will not let them play together. Interpreted languages, on the other hand, will try to make it work, and it can be a little bit more dynamic in the things that it's trying to do. This is one of the things that it took me a long time to understand this concept, for sure. Wacom, I think. I have a Cintiq. Yeah, sure. I'm going to keep saying it wrong forever. So a string can be a number without an int or float value. So yeah, so you can have a string of the number 5, and actually I have some examples on the next slide. You can have the string number 5 that's not the value 5 as a number, and so that gets really confusing to people. And so here is what dynamic typing looks like. So JavaScript. JavaScript is a programming language, super duper popular. It runs the internet. It's the language of the web. The types are evaluated at runtime, and type errors present themselves at runtime. So in JavaScript, you can do this. These are actually two different data types here. This right here, let's see if I can figure this out. This right here, This is an integer. Okay, so that's one type of data. This, on the other hand, this is a string. All right, so remember, think words and phrases. The reason is because the reason that we know what type of data each of these are is because this one doesn't have any anything around it. It's just the number 5. So it's an integer. It's a whole number. It doesn't have a decimal point, so it's not a float. It's just an integer. We know this one is a string because of those double quotation marks, okay? And in JavaScript, it'll say, hey, when you do 5 plus string 5, I think I know what you're trying to do. And this actually may not be correct. It may not do this anymore. But you can get some weird results. The integer 5 plus the string 5 equals, it might say equals 55 in a language like JavaScript or maybe Python. I actually think Python won't let you do it. But some other Ruby might let you do something like this for dynamic languages. It'll try to do something called type coercion, and it'll try to make that type fit, and it'll assume it'll infer what you want it to do. It'll infer what you wanted that data type to be, and it'll say, hey, I think you're trying to do something like this. I'm going to make it work so that the program doesn't break or fail. So interpreters may infer a type in order to make the code run properly. So it's like, hey, I'm going to try to make this work. Okay? I'm going to do my best to make this work. Languages that are static generally do not allow you to do this. The types are evaluated at compile time. And so when there's an error, it'll present itself right up front. And so in Go, if you try to do the integer 5, remember we said this was an integer right here. This is also very weird using this tablet. So this is an integer. We said this is a string. I don't need you to remember that they're that. I just need you to remember that there are 2 different types of data. They're 2 different pieces of data. And Go will give you this error. It'll say, hey, I cannot convert 5 type string into an int. I cannot turn a string into an int, and invalid operation mismatch types. I cannot combine a string and an integer. And these rules are one of the biggest differences between the 2 types of languages, between static languages and dynamic languages. And this is where people get confused. This is where people get uncomfortable. This is where people feel like static languages are so much harder. They're not harder, personally. I don't feel like they're harder. They do have more rules. They have more rules, okay, that you have to abide by. And so that's one of the reasons Go is a static language. And these rules, we're gonna learn these rules up front. It is much easier to learn all the rules, learn how to program with all the rules, and then move to a language that doesn't employ all these rules than it is to learn a language first that does not have any of these rules and then try to go to a language that does have these rules. It's important to know the differences between these types of data, and that's what we're going to be doing here. So another thing in something that's static like Go is when we make a piece of data, let's say we make a piece of data, you don't have to know what this means, but let's say we're going to make a piece of data that's going to be a number. We have to tell the computer what type of data that it is, because we don't want to change it later. It's gotta, it has to know exactly what type of data that is. The types of data matters. We have to say, hey, X is going to be an integer, or X is going to be a string, or X is going to be a float. We have to tell the computer what it is. And then throughout our program, that data must remain that type of data. It is very strict. So sometimes instead of dynamic versus static, you will hear static languages called strict languages. You might hear it say strict typing, strict type, strictly typed language. You'll hear that as well. It's very strict in the way that you work with the data. And so this is what we're talking about when we talk about types. It is the types of data. Okay. All right. So we're getting through it. I'm gonna get you out of here pretty quickly today, I hope. So GOLANG. We're gonna be learning Go. Okay. We have reasons. There's reasons for this. I didn't just choose a language because I liked it. I've actually I fought with myself for many hours trying to decide what to do this with. We've done this class before, or not this class in particular, but we've done intro to programming classes where we've done a little bit of GOLANG and a little bit of Python. We've done it with just Python before as well. We've also done it with JavaScript and Python. We are doing purely Go for this entire course. What is Go? Open source programming language that makes it easy to build simple, reliable, and efficient software. if you're new to the game, I personally hate stuff like this because they all say stuff like this. I don't know what that means. I don't know what that means. It's a programming language. I don't know what makes it easy. Does it make it easy to build? I mean, to some people, yes. But I hate when they lead with things like that. It was designed out of Google, and it was designed to solve some of Google's big challenges. So it is considered to be more of a systems language, something that is designed to run against systems and to help manage and orchestrate and do things with servers and systems. But it is much more versatile than that. But that is what it was born out of. That's why it was created originally, to kind of handle some of Google's major challenges. It is statically typed. So it is a statically typed, strictly typed, compiled programming language. So that means that those rules are going to apply. Okay. The data, the types of data are going to matter, and it's compiled. So before we run the code, we're going to have to compile it. That's not exactly true. Go actually has some cool stuff built in to actually make it so that you don't have this. And this is another reason why we're using Go. And we can actually just make a change to our Go code and run it, and it'll do some on-the-fly compilation for us, or compilation for us, and make it easy for us to do the things that we want to do. Yes, K8s, Kates, Kubernetes is built in Go. A lot of DevOpsy tools are built in Go. Docker, Kubernetes, Terraform. Almost all the stuff from HashiCorp is built from Go. It's becoming a much more popular language. The mascot very clearly is a gopher. Yes, Docker is a Go tool. It's built in Go. It's a gopher. The gopher makes some sense. It makes some sense. I like the gopher a lot. I have gopher stickers everywhere. I am a fan of Go. I'm really, really a fan of Go. I didn't know. I felt like I didn't really know how to code until I learned how to write Go. I learned Python. I had learned a couple of things. I have been using them in my job, but I didn't feel like I knew what I was doing until I learned Go personally. So Go holds a special place in my heart because it kind of led me to the promised land of making sure I understood what I was really doing. The Alt F4 stream, welcome, sir. You just came in and just started talking and having a good time. It's been so long. If you all want to learn everything, the Alt F4 stream is someone you need to go follow. Does a lot of DevOps stuff, builds applications, does cool tools, does a bunch of amazing stuff. Super entertaining streamer. Him and Atoda came through earlier, said he's super busy. They do some dope stuff, play games, help me learn a ton. I lurk in you all stream very, very often. But a great place to also learn how to put this stuff into action. We are learning Go. I don't know if you're doing anything Go related, if you're building anything with Go right now, but it might be a good place to go see someone actually using Go to build some cool stuff. All right, so why are we using this? Well, it's compiled. And again, because it's compiled, we're gonna have to follow some rules. Because it's compiled and because of number 1 and number 2, we're gonna have to follow some rules. We're gonna have to learn some rules, and we're gonna have to think about what we're doing a little bit more. This is gonna make you a better programmer. I believe this will make you a better programmer. Having to think about these rules, to know these rules, and to learn these things, to do what you need to do, I think is very, very important. You have to be very explicit. And so people who know other languages like Java, where you have to be very verbose and things like that, you might say very explicit, not so much in Go. In comparison to something like Python or JavaScript, you have to be very explicit about what you're doing. You have to say, hey, I want this thing to be this thing. And if it's not that thing, it's not going to work properly, and that's very, very important in Go. And I want us to learn that. It's going to make you have to be, again, you're going to have to think about what you're doing. It's going to make you better because it's going to have you stop just guessing. It's going to make you think very strategically about what you're doing. Readability. Go actually has a built-in formatter, and so everyone's code is actually going to look the same. It will format your code the same way. Some people love it, some people hate it, but you're going to write your code, and you don't really have to worry about like spacing and things like that quite as much, because Go is going to format your code in the same way. So our code is going to look very, very similar. It's going to be structured the same way. This makes it easy to read. Okay. It doesn't, I'm not saying Go is the best language ever, but it's going to make it easy to read. It's wild going to read someone who's been doing JavaScript for a long time, and they've structured their code in a consistent way that people have gotten used to, and then watching someone who just started and they just have got like, stuff all the way to the right and with 2 lines over to the left and lots of space in between and like all kinds of design choices that are weird. It's going to make your code a lot more readable, and it's going to make you be able to read code better. And reading code is almost as important, if not more important, than writing the code as well. And so it's going to make you a better programmer as well. Some of the other reasons is, one, it's pretty in demand. Right now, people are usually looking for more senior level Go programmers. It's still a little bit niche in comparison to some of the larger languages, but there are tons of jobs for it, and it's growing. It's one of the most liked, most loved languages out there as well. Every single year, Stack Overflow does a developer survey, and so does GitHub does one as well. But on the Stack Overflow survey, Go is always near the top of programming languages that programmers want to work with, want to learn, that companies want to build things in. And so it's it's got a lot of momentum. It's still growing very quickly. So a lot of opportunity there as well. And again, you can stick with Go and get a job 100%. But even if you decide to go something else, I think it's going to teach you enough to be able to move to another language pretty simply. And as far as compiled, statically typed languages go, it is by far the easiest to write in. Some of these can be very, very difficult to write in. It's super simple and comparatively to write in Go. And so here's a little chart. Here's a little chart on some of the programming languages that are out there. So over here we have fast and fun for humans. Okay, so the higher up here, the more fast and more fun it is for humans to write, and then fast and efficient for computers. So you should already be thinking, everything that's over here, not very fun. It's pretty low on the fast and fun for humans. But we said compiled languages are much more efficient for computers. So, obviously these are compiled over here. And look at these up here. These are all very fun and easy for humans to write, but not very efficient for computers. All of these things are interpreted here. And then we have JavaScript. JavaScript is also interpreted. And a little bit faster than these things here. Then we have Java. Java's usually, in a lot of programming courses, a lot of computer science courses, Java's a big language that's taught because it's got all these rules as well. But Java is very, very verbose. And so it's a lot less fun fast and fun for humans to write, but it's still pretty fast and efficient for computers to use. But Java is this is one of those, I'm gonna write bytecode here. This is the one that compiles down into an intermediary format, and it runs on the Java virtual machine. But Go is right here. It's look how high it is on the fast and fun for humans to write, and look how high it is on the fast and efficient for computers. Go is compiled and static. So this is kind of Go is kind of in the sweet spot here for what we want to learn. It was fast and efficient for computers, but also fun and fast for humans to write. Not as fun as Python or JS, because I'll show you some comparative lines of code. And yes, Go takes a little bit more work to be able to get some of those things out. But yes, I didn't know JS was faster than Python. Yeah, the first time I saw this chart, I didn't know either. I don't know. I've been using this chart for a long time. I don't know if things have changed, but I don't think so. I think this is about right. Yes, Go is kind of in the sweet spot. It's pretty dope. And so here's just a little bit more. We've kind of already talked about all this stuff. It's popular for cloud-based servers. I put this in here so that you know what a lot of Go is used for. It is helpful to know what languages are used for. Go is used for a lot more general purpose things nowadays, but I think it's pretty important to kind of throw this out here because this is kind of what it's known for. A lot of networking stuff, a lot of systems stuff. Like I said, a lot of DevOps tooling. A lot of tooling is built in Go. Terraform, Kubernetes, Docker, Prometheus. A lot of these things are built in Go. None of that might make sense to you now. You might not know any of these tools. That's okay. Completely fine. You'll know more and more about these things later on. Having this information here is something that you can call back on later and to figure out what Go is good for, because people might ask you these things in interviews maybe, but it's good to know. Definitely good to know. Go in the real world. This is just about money. Most loved and dreaded languages. Go is, pretty high on the most loved. This was from a few years ago. Average Go developer salary. This is not to say this is accurate, but it is to say that, learning Go, having the skill of, knowing the Go programming language is worth good money. It is 100% worth good money. That's not to say you're going to get 150 grand your first role, but let me be very clear. The tech market is wild right now, and in my opinion, is going to be for the foreseeable future. Salaries are astronomical. The amount that you need to know to make some massive salaries is pretty low. Some people just finished the course that I taught in person. For their first programming roles, for their first tech roles, some of them went from making 40 or 50,000 to making 80 and 90,000 in the first role. After you get a year or so of experience, it's absolutely, depending on where you live, it's not unheard of at all to move up to the 120 to 140 range nowadays. Like things have kind of changed massively. Once you're a mid-level, mid to mid-senior, once you have, that 3 to 5 years of experience, mark is the sweet spot. I really do think where we are now, in most places, most roles have gone remote. I really do think you should expect to make, at the 3 to 5 year mark, you should be at least at 125, 130, and you could probably make up to 200 if you are, good at interviewing, and if the things that you've learned over the past 3 to 5 years have been valuable. And again, these are, if you're not in the United States, I'm speaking about United States salaries. Specifically, I'm not all knowing in this thing, but I do help people get hired. I do talk to companies. I do see these things every day. Salaries are getting very, very significant. Entry level roles are getting a little bit harder to come by because they're paying so much more. Entry level roles are, in the $80,000 to $90,000 across the board. Now, you might hear of FANG companies, they're paying entry level folks big money, but I'm talking about just standard roles from companies, in your area, paying really well. We'll talk about salaries. We'll talk about how to search for salaries in your area. Localization isn't quite as important now that COVID has kind of changed the landscape of things. You can 100% get a remote job. Most jobs are, maybe not most, but a lot of jobs are going remote right now, and it's driving the price of roles up. Are these more DevOps SRE roles or like traditional developers? For Go, so that's very interesting. There are 100% lots of, so what's right here is for Go developer roles, like specifically normal Go developer roles. There are a lot of DevOps and SRE type roles that are looking for Go, but that require a little bit more knowledge of other things. Those roles pay even more. I'm kind of specifically talking about Go developer roles right now. Again, like I said, you're not going to come out of the gate making 150, but this is not unheard of for having 2 to 5 years of experience. Really, 2 to 5 years of experience. If you're in the United States, you could 100% be in this area for a tool like Go. Here's a little website that shows you some of the differences, that talks you through some of the differences between programming languages. You don't really, this is just for you to kind of look through. Again, part of your knowledge is going to be having an understanding of, what are the differences between Go and Python, and why would someone use one over the other, and what do people use Python for, and what do people use JavaScript for, and having a general understanding. These programming languages, they are just tools though. So, you generally want to use the best tool for the job, but I could do all the things that I use Go for. I could use Python to do, I could use JavaScript to do as well. And so, they do that. Like, using one isn't going to be like, oh, I can't do all these things if I use this language. But they provide different tools. They provide different benefits that might make they might make it the best tool for your job, and it's up to you to be able to identify some of those things. But it's helpful to be familiar with the differences between programming languages. It helps you understand, what's going on, what they're good for, what they're not good for. It helps with conversation and interviews. Helps a lot. So take a look around. I did a bunch of SRE DevOps interviews a few months back, and Go and Python were always talked about. 100%, I'm a DevOps. That's my thing. DevOps, infrastructure, site reliability engineering. That's my space. And yeah, Go and Python are pretty much the main two languages I see that companies are using to do any programming on that side of things. So can't go wrong with either one. Multiple technical challenges I had were Go or Python. Yep. Usually if you're given a take-home exam, take-home test, take-home challenge, it'll be one of those things. The best way to get started is to find a company that's using Rails or Spring and moving to Go. That's a good idea. I did this 2 years ago, porting Rails to Go. Oh, man. And led to my current role at Arden Labs. Dope. First off, H Brock 001. Arden Labs is dope. I was actually planning on taking a Kubernetes course from you all. Yeah, that's pretty dope. That means if you're at Arden Labs, you probably know a ton, and you've probably done a lot with Go, and so we might be asking you for all of the questions. That's pretty cool. That's pretty interesting information as well. Like, to think about looking at companies who are porting and moving over. There are a lot of companies. Go is a newer language, and they have old legacy code bases that are built in a different language, and they're moving over. And so there might be a lot of opportunities at those types of companies to come in and do some cool things. That's pretty awesome. I think there should be a programming language that's done only by singing. I agree. That was a good note. I really do agree. So look, I've been singing a lot lately. I really think I'm a really good singer, only because our house has a big dumb bathroom. It has a bathroom that's a waste of space. I'm gonna post it for you all so you can see it's such a waste of space. I like it's significant. God, it really might be 1/5 of the house. I'm so serious. And all that's in there is a shower on one side and a toilet on the other, and the sink. It's nothing. There's nothing there. It's amazing for singing. I am the greatest bathroom karaoke singer, specifically because my bathroom makes it so. And as soon as that programming language comes out where we can do it just by singing, I will spend all of my time there, and I'll be the richest person ever because I'll be the best singer, making the best applications, and no one will be able to stop me. I'll just take over the world. Call me Elon, but with an A. Okay, I'd be the new Mr. Musk. Okay, that'd be me, 100%. Is anyone hearing about Rust? Any use out there? Man, so Rust is another big language that's it's growing. It's like blowing up in popularity. Very difficult to learn in comparison to Go. Very difficult to learn. Companies are definitely using it. I don't see as many people using it, companies using it as Go, but there are definitely people using it. Good thing to learn, but if you're new, if you're just starting to learn, I'd stay away from Rust for a long time. What are some good neighborhoods in Baltimore that you recommend moving to? This one's tough because Baltimore, one, everyone has a different idea of what good is, and Baltimore is almost block by block. So like even if you move to a good area, if you're talking about Baltimore City, you're not away from what people consider the bad parts, or you're not away from crime. Like it exists kind of throughout the city. But maybe some good places, Fed Hill, my mind is blanking because I'm no longer, I've lived in the city for the past 8 years, and I just moved to the county. So now, I'm a county man. I'm a county man now. I don't really know anything about the city anymore, but yeah, like places like Locust Point, maybe, and like over by man, my mind is literally blanking on the names of these places. Harbor East, really nice if you got some money. Canton is probably a good place. I hear places like there's some village that everyone talks about that I don't know. I think Hamden's okay. I don't know. Mount Washington, I've heard good things about Mount Washington, but I don't really know because everywhere I go in Baltimore, it's everywhere seems mostly the same to me. You know, I don't know. But yeah, Fells Point is expensive but nice. But yeah, dope. Dorothy, so are you all in the DMV area? I think you said you're in the DMV area. Congratulations, dope. Baltimore club dancing should be a workout trend. I agree. Trying different projects written in Rust, like Alacrity, I like it. I love Starship. Starship's amazing. I love Starship. It is what I use, and it is what I'm going to recommend that you use once we get there. And Nova, dope. Winchester, we will one day we have to. You know, I'm down in the DC area all the time. We'll find some time. We'll grab a coffee. We have to. We got to have a DMV meetup. We really do. There's a number of people in Annapolis. We really need to have a little meetup, for sure. Well, I'll put that together. I'll talk to my wife. She's better at making things happen than me. So I'll talk to her, and then she'll make it happen, and then I'll just share the information with you all. All right. Oh yeah. Dope. Amazing. See, you see this? This is great. I love it. So how do we write code? We're not gonna talk about this tonight. How do we even write code? This was something called text editors. We're gonna spend all of next class learning about text editors. We're gonna be using this one right here at the top. This one is called VS Code, Visual Studio Code. It is a Microsoft product. It is probably the most influential Microsoft product that has come out of Microsoft in a very, very long time. It's an open source text editor, so it helps you with programming, and it's great. It's almost universally renowned as great. There are people who would say it's not great. Mostly the Vim users here on Twitch, people like Primogen, people like Tej DeVries. There's a bunch of people on Twitch who are Vim purists. I do use Vim as well. I use them both. I do like Vim a lot. You shouldn't use Vim. I'm gonna be honest. If you're a beginner, you should not use Vim. VS Code is the answer. Don't let anyone tell you otherwise. This is the answer. We'll talk about this all next class. I just wanted to tell you about it. It's not even installed on the system. The system is completely fresh. So you'll see how to install it. You'll see how to work with it. We will do a whole overview of it, but it is the answer. Nothing wrong with Atom. I've actually used it pretty recently. It's gotten so much better. There was a period of time where Atom was slow. So Atom is a text editor made by GitHub, open source text editor made by GitHub. Great. It has become better, but there was a period of time where it was super duper slow. Now it's much better. It's cool. I just think VS Code is so good. If you don't have a specific reason, I guess Atom is now owned by Microsoft. That makes perfect sense. But if you don't have a specific reason to use something else, I just can't think of any real reason to not use VS Code. I really can't. It's very, very good. It's very, very good. A lot of people, this used to be the thing. Sublime used to be gigantic. They just came out with Sublime Text 4, I think, and I want to check it out because I paid for Sublime 3. JetBrains has a bunch of paid IDEs. They're actually pretty cool. When you get deeper into your development journey, you might find that JetBrains is some of the JetBrains products are really good for you. Notepad++, this is the OG on Windows. You can use it if you want. No reason to. Lex, thank you so much for the Twitch Prime sub. Yeah, Vim Tutor's dope. Prime is a beast of Vim. Like him and TJ and all them, TJ DeVries, he's a streamer here. He's actually a core contributor to NeoVim. And I've gotten to dive into NeoVim. I'm a NeoVim user in my daily day-to-day things. I use VS Code too. Like I actually go in between them. I use NeoVim more than I use VS Code. But it's more so because I enjoy using it, not necessarily because it's the best tool for the job, to be honest. VS Code is very, very good. We're learning about IDEs. So IDEs are called integrated development environments. So text editors, there used to be a day and time when IDEs were the tool that you needed if you wanted to really build a big application. And it would basically, it's just an application with a suite of sweet tools and stuff that makes writing programs much, much easier. Things that help you debug things that help you find out information on what code does, things that help you search your code for, occurrences of things. Text editors were just programs like things like Microsoft Word that just modify text. But nowadays, there's been a kind of merging of sorts. VS Code has an extensions library. All of these really have extensions libraries that allow you to basically build them into your own integrated development environment. They allow you to tailor this text editor, this tool that's just designed to modify and edit text, and to be able to use it the way that you want and have all the things that you need to make your life really, really easy. I'm serious. Nowadays, programming is much, much easier because of these things. And VS Code is one of the dopest. All right. Also, we're going to talk about how much time do you have left? Cool. The last thing we're going to talk about here is we're just moving fast. We're moving through it, and I'll leave the end. I'll save if you have any questions, write them down. I'll save the end for any questions. The last thing I want to talk about, we're going to spend time on this next class as well, but I want to get you introduced to this right now. And this is binary and encoding. And this is one of those things where I'm going to introduce you to it, get you a little bit confused about some things, and then next time we'll clear it up and you'll feel better about it. So remember we said that these computers only understand ones and zeros, on and off, yes and no. We're going to talk about, and actually, you know what? I will pull up, let me get a link really quick from a computer that I'm logged into this on. I'll actually show some of the slides to help you with it now. Let me get it over here. Change, copy link. All right. And so our slides are gonna be different. This is a simpler form of the slides. But let's talk about this really quick. Get you introduced, learn as much as we can. All right, so computers, they read ones and zeros, okay? They understand ones and zeros, on or off, yes or no. They understand binary meaning two. Let's talk a little bit about how this works, and let's talk a little bit deeper on how that binary data is consumed in larger pieces of data, and let's start to get an understanding of some of these things. So bits, okay? So one, binary is just, like we said, ones and zeros, on or off, yes or no. A bit is a binary digit. Okay, so that's, binary digit, a bit. Okay, this is the actual one or zero, the on or off, the yes or no. It is the smallest unit of data in a computer. Okay, so a bit is the smallest unit of data in a computer, 1 bit. And that bit is either a one, or for all intents and purposes right now, the way we represent it is ones and zeros. So right now it's a 1 or a 0. A byte, you've probably heard of this. You probably talk about how many megabytes of RAM you have, how many megabytes or gigabytes or terabytes your hard drive is. But bytes, a byte is 8 bits, okay? Let's get rid of this. A byte is 8 bits. This is not super useful for you to know right now. I've never heard anyone say it. Oh, what's up, Thug Muffin? Good to see you. Thanks for coming through. But half of a byte is a nibble. Great thing to know. You will never be asked about that. The only time I've ever had to refer to this or know that was here. But just, a fun little thing that you now know. Half a byte is a nibble. Half a byte means it's 4 bits. Okay. Yep. See, when I found out, I was like, that's good information. Everyone needs to know that. It is. I should have given a not safe for work. I I should have. But half a byte is a nibble. And so, you know what's funny? I may be telling you all this, and it may have been a joke. It may have just been a joke, but I'm pretty sure it's correct. So if it's not, maybe it's not. Maybe I read a joke and I thought it was real, but I'm pretty sure that's correct. But 8 bits. A byte is 8 bits. So the smallest unit of measurement in a computer, smallest unit of data is a bit. 8 of those bits makes a byte. Binary, bi meaning ones and zeros, on or off, yes or no. And how do these ones and zeros represent data? So let's start we're gonna get to this ASCII table in a second, but first let's just start with like binary is a base 2 system. We are used to working in a base 10 system. And this part's, the first time someone ever went over this with me, I was like, back to math. I don't like any of this stuff. I don't know what that means. I don't really remember any of this. It's okay. We're gonna talk through it. It's not as complicated as it sounds. But we're talking about, you're used to, zero. You're used to the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a base 10 system. Oops. Okay, this is base 10. There are 10 digits here. Binary, because there's only 2 digits, this is a base 2 system. Okay, base 2. And the smallest bit is one of these options. Okay, so the smallest piece of data can be a 0 or a 1. Not both. It can be a 0 or a 1. So byte might look something like this. A byte of data is going to have, let's see if I can draw a full box here and split it up correctly. I don't know what I did, but I broke it. Oh, this is a problem. Okay, there we go. Let's erase this here and let's start over. Let's go with a byte. And our byte is going to be a box that's going to be split into 8. So 1, 2, 3, 4, 5, 6, 7, 8. All right, so now we have 8. A byte is going to work like this. And so, where do I want to go with this? So let's do something like let's represent a base 10 number. We're used to doing that. We're used to base 10, and so we can represent pretty much anything with these ones and zeros. Kinda. We're gonna learn about hexadecimal and all kinds of other stuff. But let's say we wanted to represent in a byte of data. How do we represent something like the number 10? Or the number 6, or the number 48, or the number 200. How do we represent that? And so the way that we're going to do that is this. The flow, this class in particular, Camp Code, is every Monday at 7 p.m. Every Monday at 7 p.m. for 22 weeks. Tuesdays, every Tuesday at 7 p.m. is Camp Cloud. So if you want to learn AWS, come through for that. And on Thursdays, there's something called DevOps Anthology Series, where we'll be diving into a bunch of things that are going to make up a DevOps course. So we'll be learning Linux for 7 weeks. If you want to come through, then after that, we'll be learning some coding stuff, some networking stuff, and blah, blah, blah. So no, not every day. Monday, Tuesday, Thursday. Yes, Monday, Tuesday, Thursday. 7 p.m. Eastern time every day. Each of those days, 7 p.m. Eastern time. All right, so a byte. Everything is base 2. So this spot over here is, you can think about it as 2 to the 1, and 2 to the 2, and 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7, 2 to the 8. So what does that mean? If you actually look at these powers, what that means is this place over here, we're used to our tens thing being like, wow, the thing over here is in the ones place, and the thing over here is in the tens place, and so and so on and so forth. You know, base 10 to stuff like that. It's I may have done that wrong. We're used to base 10. But what this means is that in this box over here, with this box right here, the max thing that the max value that I can represent here, 2 to the 1, or is it 2 to the 0? Sorry, I messed that up. 2, 0, 1, 2. Yeah, I messed that up. The same thing over here. I don't know how to erase. Let's do this. Oh, that's nice. Let's start over. So this Wacom tablet is new to me. It's super new to me, and it's really like the first time I'm using it. So it's kind of weird. So we'll do this. So yeah, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, and so on. That means the box that's in the first format, the max value can be as 1. 2 to the 0, anything to the power 0 is 1. That's any number raised to the 0 power is 1. So the max value we can represent in the first bit of data is 1. That means the max thing, the max value that we can represent here is 2. The max value we can represent here is 4. The max value here is 8. The max value here is 16. The max value here is 32. Max value here is 64. And for the last 2, 2 to the 7th, it's going to give us 128. And 2 to the 8th is going to give us a max value of 256. Okay, so 8 bits. Each of these individual items is 1 bit. That's 1 bit. That's 1 bit. That's 1 bit. 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 There are too many. 1, 2, 3, 4, 5, 6. Oh yeah, there are too many. Ignore that. Correct. So what happens here is this is the amount that each of these can hold. This is the amount that it can represent when put together. When you take 1 bit and combine it to the next bit, combine it to the next bit, and combine it to the next bit. This is what they can hold. Okay. But remember, each of these can only be 1s or 0s. So how does this work? Well, over here to the right, if we wanted to represent the number 0, what would go in this box? It will be 0. Okay, so 0 in this box will be the number 0, and so basically all these would be 0 over here. And this would equal 0. If we wanted to represent the number 1, the way that we would represent the number 1 is we would change the first box to a 1. So 0, 0, 0, 0, 0, 0, 0, 1. And that would represent the number 1. Right? Okay, that makes sense. The first value, the first bit can hold a maximum of 2 digits, 0 and 1. That means if we want to represent the number 2, how do we represent the number 2? Well, the way that we represent the number 2 actually is we got to look at what the maximum value we can hold here is. This one can represent the number 2. So, okay, we can't just put the number 2 in there. The way that we represent the number 2 is to put a 1 inside of here. So that gives us the value of 2. And over here, we actually have to put a 0 because remember, this box can hold 1 value, this box can hold 2 values. So the way that we represent the number 2 is 1 and 0. That will equal the number 2. If we want to have the number 3, what do we have to do? We have to fill up this box to give us 2. And then we have to fill up this box to give us another 1. So that gives us 3. Very confusing, I know. Control Z that. Okay, so if we want to do the number 4, we can't make 4 out of these 2 boxes because, you know, it's only 2 plus 1. The max that we can get out of these 2 bits, these 2 bits can only give us 3. So to make the number 4, we actually need to add a 3rd bit. So if we want the number 4 is 1, 0, 0. That equals the number 4. If we want to make it 5, we need a 4 here, and we need a 1 from over here. So 1, 0, 1 is 5. And if you want to make 6, you now can use the 4 slot and you can use the 2 slot, but not the 1 slot. And that'll give you 6 and so on. So as soon as you know how much each bit is worth, as soon as you can recognize how much each bit, the maximum amount each bit is worth, it gets relatively, I would say it gets relatively easy, but it allows you to pretty, if you write it out, it allows you to be able to visually look at it and figure out how to make a number. So all you got to do is remember to know how to double 2. So you start with the 1 over here. It can be 1, then it can be 2, then it can be 4, 8, 16, 32, 64, 128. All right, so these are all of our bits. So if we wanted to make the number, someone throw a number out in the chat. Throw out a number between 0 and 255, and we will make that number. We will represent that number in binary. 129. Okay. So for number 1, we'll do all those. We'll do 34 after that. How do I do? Just one undo. So 129. The first number is 129. Would be. We can go to the highest number that we need. So we have something that gives us 128. So 129 would be 1, 0. I don't need any of these. I only need 1 more. So I'm gonna go 1, 1, 1, 0, 1. This is 129. Okay? So we got 128 from this bit all the way over here, and then we added 1 from the single bit over here. If we wanted to do, we're not going to do 34.5. Thank you so much, Blah. I wouldn't expect anything less from you. To be honest, you actually warmed my heart by trolling me like that. We will talk about stuff like that though. If we want to do 230, we need to do. You're gonna make me do math. So for 230. We're gonna go 1. So you can use a calculator for this, and I'm gonna use a calculator for this because simply, I'm lazy. So 230, we subtracted 128. Okay, so we have our 128. So we have 102 left that we need to represent. We need to represent 102 more pieces of data. So I'm gonna go ahead and then throw in the 64. I think that's gonna work. So I'm gonna throw in a 64. So now I've got 128 plus 64. How much do I have left? I have 38 left. So I'm going to go 32. Okay. And after my 32, I have 4 left. So if I only have 4 left, I'm going to go 0, 0, 4, 0. And that's going to give me my 230. Then we're gonna do what else we got? 235. So let's go 1, 1. We just need 5 more. So if we need 5 more from what we had, then we go 1, 1, 0, 0. That's gonna be different. Because hold on, let me that was going to be a little bit different because I can't add, we already have a 4 in there, so I can't just add 4. So let's do it the real way that we're supposed to do it. So 235, we're going to do 235 minus the 128 that we did. Not 125, minus 128, minus 64, minus 32. Wait, did I mess up in there? I'm starting over because I feel like I messed up. 235 minus our 128 minus our 64 minus our 32 leaves us with 11, 8, 9, 10, 11. Got it. So it's going to be, we minus our 32. That left us with 11, 0. It's going to be 1, 0, 1, 1. 230 is wrong. 228. Hold on, let me see. 228, not 230. 1, 1, 1, 0, 0, 4 is 228. Hold on, let me be the judge of let me be the judge, chat. No, I'm joking. Yes. And so doing this by hand is annoying. And obviously it's not. So one, I'm showing you how to do this, not because you're going to have to do, like, I'm going to give you problems to do this. Your job as a programmer is not going to be to do this at all. Your job as a programmer is never going to be to convert these things. I want to show you how it's done, how we can convert from one to the other, so you have an understanding of how it works. But you can make a lot of money, which I have done without being good at this. But let me confirm that. So let's go 128. All right, plus the 64 plus the 32 that we have here. And so I'm going with the 230 here plus 32. You're correct. We did, this is what happens when you fat finger. So when you do it right, when you actually do it right, when I actually follow what I actually did, that is exactly what happens. So for me to get from 128 to 230, what do I have to do? I have to add 2. So this needs to be a 1 right here. You see, you make mistakes. Thank you. There we go. Hopefully that's correct. Now, someone please fact check me. That's right. But just showing you how this is done. I did not. I'm not joking with you. When I did go to school, I started out with computer engineering. Then I went computer science. I got weeded out of all the computer science courses. When we were in that class, I did not understand because no one drew out the base. Like, no one just drew out a simple 8 square byte that showed me what the maximum value for each byte could be. I don't know why that wasn't the first thing someone did for me, but I didn't understand it because of the way it was taught to me. The first time someone did this, it made 100% easy sense to me. All right, so with a byte, the maximum value, so with 8 bits, which is a byte, the maximum value that you can represent, if you add up all of these, is actually 255 because it includes the number 0. So 0 to 255, you can display 256 total values. Okay? So that's the maximum number you can show with a single byte. So if you would like to show more numbers, you need to add more. You need to add more bytes. You can say add more bits, but the way that computers usually do information, yes, bits is the smallest. A lot of things get allocated via bytes, via 8 bits at a time. So if you wanted a number that was bigger than 255, you would actually need more bits to be added to be able to represent that type of data. There are a number of different ways to take this ones and zeros and represent data. Okay, a whole bunch of different ways that make it easy for you to translate these ones and zeros into something that matters. What's up, Strager? Welcome to the channel. You're coming in right at the end of the course, but today is day 1 of Camp Code. It is this is called Base Camp. This series is called Base Camp, which is a foundational series to help you learn computer science concepts, programming computer science concepts. Today was really an introduction to programming. Right now, we're just doing a very light little bit with trying to understand binary and converting binary to decimal. And and we're kind of messing around with it right now. It's something that we're going to dive into next class, actually. But we wanted to kind of get a head start on it and learn a little bit about it and learn how you take ones and zeros and get something like letters or other numbers or whatever out of ones and zeros, if that's all computers really understand. But welcome, come on in. Thank you so much for the raise, Traeger. Shout out again, another person who you can learn a ton from. Usually, I usually catch you doing a bunch of C stuff that, a little bit, I'm not good. I'm not good at. I'm gonna be 100% honest with you. I'm not good at. That's why I'm over here writing Go. We will be learning Go in this course. If you're interested in learning Go, this is perfect for you. But yeah, thanks so much for coming through. Good to see you. Been a while. But yeah, so this is how you would do it. Again, you don't need to know how to, right now, you don't need to know how to do it. I just kind of want to show you that you can take the ones and zeros and you can represent different types of data. The last little bit, we will actually practice this more next time. But the last little bit is how do you get like letters and numbers? Appreciate it. We'll do. Thanks for coming through. How do you get letters? Not letters and numbers. We know how you get numbers. How do you get letters? Well, there are different standards for something called encoding. And so ASCII is one of the ways that we can turn binary and ones and zeros ultimately we can make it represent we can make it represent letters. And the way this is done is actually first the ones and zeros actually end up representing a decimal number first. So it goes from the ones and zeros to a decimal number. And I don't know why it won't let me, every time I make the page bigger, it makes this smaller. But what you can see here is actually that these decimal numbers, the decimal number 65 actually represents the character A. So this is a standard that's set up to say, hey, I would like when we're representing, to represent the number A, I would like for the decimal digit 65 to be represented. We know how to do that. And that's going to be converted to an A. And for the letter B to be 66, and for a lowercase letter a to be represented by the decimal number 60 or 97. And so you have this chart here. And so if you look through, if you just Google ASCII table, you can see this chart and you can see what decimal numbers and what hexadecimal numbers will represent different characters in the alphabet. Now, ASCII, it's called the American Standard Code for Information Interchange. This is one type of encoding normally used in places like the United States. This is not the only form of encoding. The same type of thing is done when you change the language on your computer. It's using a different method of encoding. This is how you represent, even when you do things like emojis. There's a standard set method of encoding that tells me what data I need to use to represent a different type of data. And so 97, the integer 97 might mean something different in a different encoding language or different encoding standard. And so that is how we get from, that's kind of how we move our way up from binary into something different. We use that representation to get us a number or to get us a different value. And we use that new value to map, to determine what we want that new number to represent. And we can change encodings so data can work in different places. But that's how we get from encoding is how we get from ones and zeros to something more useful to you and I. Very light introduction to encoding. We're gonna dig super deep. Remember I told you this class is gonna go super deep. So we're gonna learn a lot more about encoding and how to convert encodings and how to work with different encoding types to make sure that you know what is going on. So yeah, so you now know the first piece of next class, so feel free to come late to next class. We'll do a little bit more. You'll also get a podcast. I really love people to dive into the base CS podcast. It's pretty dope. There's a bits, bytes, and binary section. I think it's like the second or third podcast that really does a good job of explaining what these things are. That's actually going to be pre-work for next class. As long as you're in Google Classroom, you will see that pop up as something for you to use. But that's it. That's it for tonight. 9 minutes over where I want it to be. But here's what I want you to focus on: tangible takeaways for this evening. Okay. Usually at the end, we'll do something called the tangible takeaways. And these are going to be the things that I want you to focus on here. One, I want you to understand that the journey that you're about to partake in is not going to be an easy one, but is 100% a doable one. And that the goal here is for you to learn how to learn and for you to be open to what's going to be coming at you. I want you to understand that you're not going to understand every concept immediately, and that a lot of people don't. It takes them years to get some of these concepts, and that's okay. I want you to be okay with being confused, at being lost, at not understanding things, because there'll be a lot of scenarios where you don't know what's going on. And I want you to take in the information. I want you to process it. I want you to think through it and churn on it. Start to really ingest it, and things will begin to make sense over time. I promise you, things will start to click. Things will start to make sense as we touch new, more complex concepts. I want you to, when you're spending extra time this week, I want you to spend time looking at and getting familiar with the types of programming languages that are out there. I want you to look around and see, what programming languages are popular. See if you can do a little bit of research, and you probably hear about 10, 15 programming languages you've never heard of. I want you to see those things. I want you don't need to know what all of them do, but I want you to know what kind of exists out there. I want you to know the difference between compiled languages versus interpreted languages. I want you to spend a little time Googling and watching videos about that. Again, I'm going to provide resources for you for those things. I want you to understand the concept of there being different types of data as we program. We're gonna spend a lot of time specifically on each type. You'll spend 2 or 3 weeks on strings and a week on integers and floats and Booleans and all that stuff. But I want you to start to try to understand that concept. I want you to understand dynamic typing versus static typing. Spend a little time diving back into that, making sure you understand it. And spend a little time. Feel free to spend a little time Googling around, and maybe if you're comfortable enough installing some of these text editors on your computer, or watching a video about text editors and starting to form some opinions and to check out some things and to learn some things about what you're doing. You don't need to do anything with the bits, bytes, and binary. That's something that we will cover again. We said that was just something that we wanted to introduce you to, now, so that, as you're going into next class, we have a little bit of head start on it. Highly recommend watching a tutorial in VS Code. Absolutely. We will be doing, I highly recommend it as well. We will be doing a tutorial on VS Code. Feel free, where the do exclamation point syllabus if you want to see the curriculum. And feel free, if you ever want to move ahead and watch some videos on some things before class starts, if that will help you I want you to feel empowered to do so. I would watch a video on VS Code. I'm going to teach you the basics of VS Code. I'm not going to teach you everything, though. We don't have time for me to teach you everything about it. But next week, we're going to get VS Code installed. We're going to get Go installed. We might get Python installed. I'm going to install Python because I'm going to use it to show you some differences for some things. But you don't need to do it. But if you want to, you can get Python installed. We're going to get Go installed for sure. We're going to VS Code set up. We're going to get some extensions installed. We'll write our first little bit of Go. You probably won't really know what it's doing, but we'll walk through it. We'll walk through the anatomy of a Go application. We'll talk about bits, bytes, and binary. There's one more topic we're going to talk about then as well. So yeah, that's it. Any questions? Does anyone have any questions about the course? Does anyone have any questions about what's going on next week? All of the reading materials and stuff I will drop as soon as class is over. As soon as we're out, I'll go ahead and into the Google Classroom, and I'll drop all of the materials off inside of there. Rings Ed, thank you so much for the tier 1 sub. Maybe share riced out VS Code settings.json. 100%. I got it. I got a lot of riced out stuff for sure. I will 100% share it. Everyone should have Python installed. Everyone who has a Mac already does, and it probably doesn't work well, and it probably is going to cause issues. But, Python's dope. Python's pretty cool. LSPs are amazing. They are. Cool. If there are no questions, we are going to do what everyone else is in. We've been rated a couple times tonight by some cool people. Let's look and let's see who's online right now, and we will head over and we will say hello to someone else's community, someone else's channel. Thank you so much for coming through. If you're interested in learning AWS or the cloud, come through tomorrow. That's what we're going to be starting our 22-week journey there as well. Yeah, come on through. Let's see who's online. I haven't done this in so long, I don't even know what I'm doing. Fogo de Chao. Hey, you know, I'm always down to raid Fogo de Chao. Fogo de Chao, if you want to say it correctly. I don't know if that was right, but it seemed right. Software and game development. Fogo de Chao. All right, who's online? Absolutely TT2 Cutie. Usually like to raid. Let's go. RW. So if you want to learn, RW Grim is dope. There's so many good people to learn from. I'm gonna try to rate people that I want that I know you can learn from. Let's go say hello to. I haven't talked to him in a long time, so this will be good. I already lost him. Is he not live anymore, or am I tripping? I lost it. Oh, it's right there. RW Grim. That's what we'll do. So we'll get out of here. Raid? Yeah. RW Grim. All right, we're out of here in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. It says his channel is intended for mature audiences. Drop by, say hello, spend a couple minutes over there. You really might learn something. Definitely check out a lot of these other streamers. They'll help you through your journey as well. Thanks for coming through. I'll see you all tomorrow, hopefully. Come on through. Or if not, I'll see you next week. Have a good night.